What's up guys, Nick Wisdom with Helidirect back to give you another top to bottom, start to finish build video of a fantastic new helicopter from SAB. In fact, this helicopter is so new, this is a pre-production kit sent over by the folks at SAB very kindly to Helidirect to do this build video for. So huge shout out to SAB and the folks at Helidirect for giving me this opportunity. If you've never watched one of my build videos before, you know I go start to finish. I will show you all of the things, tips and tricks along the way, tell you a couple stories as we build. Try not to bog you down with watching too many tightening of screws and edit all that stuff out, kind of speed time up when necessary, while going into great detail. Even if you're not building this helicopter, I guarantee if you've never built a radio control helicopter before that you will learn something from this video. All right, so let's dig in. Let's go over to the manual on the first page. Page 5 is actually the first page of the manual, so this is going to be sort of a four-step process here. We have our transmission group, which is already pre-assembled at the factory, but I'm going to show you the checks I do to make sure that's okay. We have our bearing collar assembly that we're going to put some servo mounts on and get that ready. We're going to prep our main shaft, and then we're going to put some of our main pulleys onto the gear as well as add our servo mounts. We're sort of building off of this main transmission unit. All right, so with that, let's dig into the build. If you look at this main shaft, there's a gap here is a little bit shorter than the gap here. So on starting, if you insert this piece onto the short side gap, you do it so the longer slit is towards the end, going out this way, right? So I'm going to slide this down. Here, again, long slit here is on the shorter gap side. We're going to spin this around, line up the holes, and drive our two bolts through that already have Loctite on them. And then we're going to tighten these both down. And then I'm going to show you a quick way to verify before you go any further, because I went further and then realized the mistake I had made and had to undo some things, which is fine. It's okay to go back and redo stuff. It's just, you know, a few screws, a few minutes of your time, no big deal. So with this tightened now, take this piece, grab your main gearbox here, and the shorter piece of shaft you're going to slide down into the block here. And then when you slide it in, the hole at the bottom of the shaft here should line up with the hole in the bottom of the shaft that sticks out of the drivetrain. And if it does, you've gotten things correct. If it doesn't, stop, go back, and do it right. Next piece we're going to do is take our bearing collar assembly and our two servo mounts, which are here. The way to know you've got this right, see the logo here? I'm going to face it towards me. I'm going to take our servo mount with the little dimple facing in towards here, and then I'm going to spin this such that from the top you'll see these two ears protruding here, and we're going to send two bolts through here, which are a pair of 2.5 by 8s. And then we'll just get this one started. Again, any assembly that has more than one screw in it, you always want to get all of the screws, bolts, whatever you want to call them. Everyone says it a little differently. I tend to use them interchangeably, which is a bad habit. But you want to get them both started and just kind of snug them both up, because you want to get this centered. The heads of the bolts actually like countersink into the mount. So snug them up till they start to make contact, and then alternate tightness. Don't go too crazy on these little bolts. They will obviously snap if you over tighten them. Great, and then if any Loctite leaks out anywhere, you can always just take a rag and clean that up. All right, that is one out of the two. We're now going to take the second ring and do the same thing on the bottom. In this case, the dimple is going to face in towards the assembly. And these are going to be parallel to the top. Bit of a tight fit there. And then same thing, another couple of 2.5 by 8s. Okay, so when you're done, you have the logo with our two pieces, two servo mounts. There, we've got our dimples sort of facing each other. So now we've got the main shaft inserted here. We're going to take our couple of assemblies here, the main bearing collar and our main pulley, and they have to work together. So you're going to sort of fit them together here. Let's get this piece here and this piece here, and then we're going to slide them down together onto the shaft, because if you don't, they won't fit. The tolerance in here is so tight that a belt barely fits. So the belt's going to go here. You can actually fit the belt on later, so you don't have to go crazy and hold that in like they show in the manual. We're going to slide that down. You'll notice once this is tightened, that'll take out pretty much all of the play in the main shaft here. And then I'm going to go ahead and tighten the bolt that goes through this main pulley first. I've already got Loctite on it. Find the hole in the shaft, line it up, get the bolt in there. It's a little fussy, there it goes. And then get that tightened down. Again, I already have Loctite on this bolt. Snug that up nice and tight, and then we're going to take our main bearing collar assembly, servo arms moving away from this main pulley here, and then we have 4 bolts with Loctite that we're going to drive through into the base. Again, a little bit of Loctite, wipe it off the excess, and then get all 4 bolts started. Just snug them up just finger tight, and then we're going to work diagonally opposite each of them and tighten them down. Okay, now you can see I've got the servo arms away from the main pulley, and now I'm going to work diagonally this side, that side, this side, that side, just alternating about a quarter turn at a time until they're all equally tight. And that's a good pattern to use for anything in a circle or square array. It helps keep things level as they tighten down. Make sure everything's in equal tightness. And then, again, don't go crazy on any one bolt. You will just snap the head, but do make sure they're good and secure. Okay, now we have our main shaft. You shouldn't have anything sticking out beyond this outside portion of the main shaft at all. And we're going to spin the interior main shaft, which is a bit of a tight fit, until we have a hole through here. So you could take a smaller driver and poke it all the way through. I need a really small driver. See, like so. So make sure those holes between the 2 shafts are aligned, and we do that because in the very next step, we're going to take these 2 shims, put them on top, and I may only keep 1. I'm going to start with 2 because I want to make sure there's 0 play in here, and then we're going to take our tail pulley and pop that on. You can see there is another hole through here that a bolt's going to go through and capture. So we're going to line that up with the hole in our shaft. And then make sure our interior shaft and exterior shaft are all lined up. I love, this is called an awl, it's just a metal pokey stick, but it's great for fishing all the way through assemblies like this. Actually could use a little bit of a longer one, but it just helps get all of the shafts aligned and kind of wiggle it and help get them all centered up on each other. And then we take our nice long bolt with some Loctite. And this is going to go all the way through our tail pulley into the threads. You only need Loctite on the very end because that's the only part that's going into any kind of threads. Send it through the flat side, through both shafts, little fiddly, little tight. Might have to kind of quote unquote screw it through. It's such a tight fit even though there's not threads until you hit this piece on the end here. It's sort of self-aligning as it gets there. We're almost into the threads. There we go. I can feel the threads are in there now. It is a bit of a tight fit here. Go slow, don't force it. There we go. And once you've got that in, we're going to take this whole assembly and we're going to take the tail pulley and pull it in and out and see if there's any play. And there shouldn't be any. And there's not. It's not moving at all. So those 2 shims were perfect in my case. Your case may be different. And by the way, this transmission has been pre-greased at the factory, so nothing to worry about there. All right, now let's take a look at the manual again. So this was the step we did here. That's the shim we put in with our tail pulley with our through bolt. So now we're going to work on this tensioner and get that set up. And then we're going to put this pulley bracket on, and then we're going to take this motor mount base with these unique set screws and get all of these pieces put together. You can see this tensioner, there is an assembly list here of all the order of components. So it is a screw and a washer and a spacer, and then our idler, and then a tension column, and then the bolt from the top. And then we will do that on both of these, get this whole assembly ready to go, and then we'll bolt it to our transmission. So let's come back to the bench. Let's get our idler components going here with our frame, kind of a unique looking frame here. Doesn't seem to have a front and a back. It looks pretty symmetrical, so nothing to stress about there. So we're going to take our, what do they call them, the tensioner columns, and just push those through both of our idlers. There's no up or down on the idlers. Do make sure they go all the way through. This one was a little bit of a tight fit. So if you have an arbor press, you can use the arbor press to make sure they're seated all of the way flush. Because if you have a little gap like I do with this one, you definitely want to make sure that you take care of that. There we go. There's mine flush. You can see I just sort of pushed a driver through it and then use that as leverage and pull down on it like so to get it nice and flush. All right, both of these will be assembled the same way. So we're going to start from the bottom. We're going to take our 3x8 and I'm just going to put it on a driver. We're going to take our washer, which is the wider looking piece. Put that on first. Then we're going to take our spacer, which is the more narrow of the two with a wider gap. And then we're going to put some Loctite very carefully on just the tip of this fastener. And then we're going to take that into the bottom of our tensioner pulley. And then we're going to take another 3x8 from the top. Some Loctite on that. That's going to go through our tensioner assembly and into here. And I'm going to use two drivers to counter tighten against each other. Don't go crazy over tightening this because it's really important that that free. And then again, make sure you don't have too much Loctite anywhere. Spooging out because that will limit. What you also don't want is play up and down of this. So check that that's not moving up and down and check that it rotates freely. Also make sure that spacer will actually fit around the tensioner column. So you want to make sure that that is aligned correctly. I don't know if you can see that, but it should be nice and flat here. Lots of free movement. Okay, let's repeat the same thing on the other side. So again, 3x8, washer, spacer, which is the one with the bigger interior diameter hole, a little bit of Loctite, not much on the tip. Don't need a lot here. And then that's going to go into the base. So I'm going to flip it this way, get that spacer aligned so it sits around that tensioner column. Then snug that side up, flip it this way. I'm going to take another 3x8 with another driver. Get some Loctite on it. And then we're going to go through the mount. And then we will counter tighten these. Not crazy tight, just kind of snug it and give it a little bit extra. Again, see there's some play up and down here, so something's off. I suspect this bottom screw is not tight enough. That play shouldn't be there. So I'm going to tighten just this bottom screw in this hand. Okay, that's good. Play eliminated. Great. Okay, that's our idler. Now we can take two of these 2.5x8s and we're going to use them to bolt it into our drivetrain assembly. So we're going to bring this piece back. We're going to go to this flat side here. You can see there are these recesses here, and that's where those 2.5x8s are going to go through into our idler assembly. So we'll get some Loctite on here. It's going to go through our transmission assembly here and then into the top. There's one. Again, going to leave that super loose so I can get this other one aligned. And our tail belt will pass through this pulley and then through these idler pulleys here. Okay, and then as we get that aligned, we can go back and forth and snug these up. Again, especially with 2.5x8s, you can't go too tight because they'll just snap. Okay, but you just make sure that that's rigid, and there we go. There is our idler pulleys, good to go. All right, one last step here. This is called the motor mount base. Kind of looks like a dog bone. You'll see it looks a little confusing initially, but there's a few cues here. So number one, there's a threaded insert at the top of this piece on the ends here and here that's going to face away from our main transmission assembly. And then these set screws have a hole for a driver that needs to be at the top of the set screw here. So here's our clue, and then we're going to take 4 of these M3x8s, and I'm actually going to put the set screw parts aside and do the 3x8s first and get that piece in, and you can see those are going to go in these 4 slots here. So let's come back to the bench. Okay, so here's our dog bone piece. These are those 2 little holes at the top that are only on one face. So those are going to go, so we're going near the motor pulley here, so on the motor pulley side, and the holes are going to go away. So the holes are here in the top. There's one, there's the other. I know they're a little hard to see, but there's one, there's the other. There's our motor pulley. Our tail pulley is underneath. We're going to take a 3x8. There's 4 holes there. Already got Loctite on this screw, and I'm just going to start it until it first snugs up. There we go. There's one. Then we'll do one on the other side. And now we'll come in and do the other 2. And again, once I have all 4 installed, I'll start snugging things up. It's funny, I'm so used to building SAB helicopters. I've had many in my fleet, including 2 I can see over there right now, hanging on the wall. And you sort of get used to doing things a certain way in the Raw series, and some of that was adopted in the Il Goblin series. And this is a bit of a departure, so it's a little bit of a slower build as you learn some of the new methods, but I'm excited to see how they all work together, as always. All right, now that I have all 4 of these tightened, let's just take a minute to take a tour through it, so to help you out. So again, the SAB logo will be towards the top of the piece. The holes here will face away from the drivetrain assembly, and your 4 bolts are from underneath. Now, let's come back to these set screws that SAB suggests we use bearing retainer compound on. I'm going to put these in dry for now, and I'm going to come back, and add that later. I'm only going to install them now because I don't quite understand their purpose. And I don't want to just slather green Loctite on them. So I could look ahead in the manual, but I'm not worried about it. They're easy to remove, so I'm just going to tuck them in here. And there we go. That is everything on page 6. So we have our motor mount base, we've got our main pulley, we've got our tail pulley installed, we've got our servo mounts, we've got our main bearing collar, and the belt. I know SAB shows you putting in, but rest assured, see right here, it fits without issue. It's easy to get on and off, so I'm just keeping it aside for now. All right, with that, let's go ahead and move on after giving the manual a quick double check, make sure we did everything in the steps. So moving on to the next page, it's time to play with servos. Shown here in the manual, and these are not included in the kit, are the SAB servo horns. I'm a big fan of them myself. And what's nice is they'll have this exact 17 millimeter spacing to 18 millimeters. If you're using a different brand, anywhere in that range will be fine. And we're going to install the balls onto the servo arms, put the servo arms onto the servos, and get them as close to 90 degrees as possible in the relevant positions. You can see here's a sort of diagram showing you the 3 cyclic servos and the orientations of the servo arms. So we're going to go ahead and get those 3 servo arms done, and then we'll get the servos mounted into our sort of sub-assembly here around the main portion of the gearbox and drivetrain. All right, let's go back to the bench. All right, I am using Torq Servos. These are Torq mini servos. This is the CL 1508-12. These run at 12 volts, and they are some very powerful mini servos. There's certainly plenty of other great choices from other manufacturers as well. This is just my personal preference. This is the Torq Servo programmer that is going to help me get the servo arms perfectly at 90 degrees. So first thing I'm going to do is plug the servo in here, and I'm going to set the frequency by pressing the frequency button till it says 760, and press enter. It's going to give me a nice beep, and now I'm on the neutral setting. So I'm going to take my servo horn, and I'm going to look at the first servo horn position here, and it's got to go close to 90 degrees, so I'm going to go get the servo horn as close to 90 as I can in its base position. And then I'm going to go ahead and take a screw, get some Loctite on it, and that's going to go through the servo horn into the spline. I'm going to do that while it's there. Now, there are a bunch of different methods for how to square up the 90 degree on the arm. You can give it the hairy eyeball and just rough it in by eye. There are some 3D printed tools, which is what I'm going to use to give me a rough 90. This is just a 90 degree square that I can hold up against and look at this little channel in the 3D printed block through the holes in the servo spline and kind of rough it in. But as I hold this in place, gives me an example of how I'm doing. And I can move the servo arm, and I'm looking to get basically to see through the 3 holes of the servo spline perfectly evenly through the adapter. And that is good and square. I'm going to hit enter. It's going to beep again, and this is now the new center point of the servo. So if I were to unplug it and replug it, which I'll do right now for you, I'm going to throw it way off center, plug it back in, and you can see it's come back to the same center point it was before. All right, so I'm going to tuck this one aside, and then I'm going to get the servo ball here and our tiny little screws that will go into the servo ball. And what I'm going to do is I'm going to put it through dry. So I'm going through the middle hole of the SAB servo hole, which I know is approximately 17 to 18 millimeters, plus it's the same servo horn they use in the manual. And I'm just going to screw it all the way through the servo horn. Now the servo horns are plastic, and plastic and Loctite don't get along really well. You don't want the two to come in contact with each other. So now I've gotten that started, I'm going to take this whole thing and I'm going to take my Loctite and I'm just going to dip the head of the screw without getting on the plastic. So you can see there's a tiny little blob of Loctite on there, and then I'm going to take the ball, screw it right down over that, and then I'm going to take a combination of a 1.5 millimeter driver and a 2 millimeter driver, and just counter tighten these two things against each other, being very careful not to over tighten it because you will just quite simply shatter the plastic servo horn. And there we go. That is one servo with the ball on it. And I'm going to go ahead and get the other 2 done, and then we'll come back from there. All right, now we've got our 3 Cyclic servos done. So you can see we have 2 servo horns pointing to the right, 1 pointing to the left with the spline at the top. So our 3 Cyclics are good. Just a quick tip here. I like to look ahead to the tail servo and take care of all my servo horns at the same time. So jumping ahead in the manual to page 23, we can see that's the position of our tail servo and where the horn goes. So I'm going to go ahead and knock out the tail servo, which incidentally is a full-size servo, and get that done right now as well. All right, now we're back on the bench. It's time to take our rear servo mount, and we're going to go ahead and get that servo installed. So make sure you grab the one with the correct orientation, which has the servo horn pointing to the right here. That's going to sit right on top here. And then we're going to grab our plastic or sort of carbon servo spacers here, and 4 of these 2.5 by 8 millimeter screws. And we're going to go ahead and get some Loctite on those and get this servo mounted. Now, the one thing I will say as you mount servos into brackets is I always like to push all of the servos in the same direction. So if I'm going to push them down and in, I'm going to do all of my servos down and in hopes that they're as close to exactly the same orientation as possible. So some Loctite through the servo spacer and then into the bracket. The first one is always a little fiddly as you try and get things all lined up. Keep these loose so the servo can float around until you have it in its final position and have all 4 screws in it. And we're going to do the bottom one next. Okay, now that I have the servo, you can see it's kind of floating around in here. I'm going to push it in and down. And I do that just so all of my servos are kind of in the same height from the swash plate. If I push them all down as low as they go, I know that they're all going to be the same height, like the spline height will be the same. And if I push them in, the distance from the main shaft will be as equal as possible. And the more you can get these things as close to perfect as you can, you'll never get it perfect all the way around. It just makes for a better flying helicopter. So anytime you can strive for to be as accurate and as similar as possible across your Cyclic servos. It's going to make a difference. That is our rear servo mount done. And then we're going to take this and then mount it into the frame. On our gearbox here, we have this sort of triangular pattern of 3 threaded inserts. This 2, front and back, are going to be where our screws that hold the rear elevator servo will go. And the servo is going to go in this orientation, so the bracket closest to me in this case, with the servo ball being even with the main shaft. And I'm going to kind of push this screw through the mount first to help hold it into the plate. Again, we're going to keep that loose so we can get the second screw aligned. Kind of just rotate that around until it starts to grab, and then snug it down. Again, these are only 2.5mm screws, so be cautious with how much you tighten, or you can just snap them. But obviously this is our elevator servo, so we definitely want this to be tight. You don't want that bracket flopping around, and that is a very sturdy elevator servo. Now we're going to take our other 2 servos and go ahead and install them on these 2 brackets here that are angled. So looking at the diagram, the ball is going to go towards the main shaft, so on the right hand side of the frame here. The servo is going to go just like that. Same way, I'm going to mount this one, and then the one on the other side is going to go with the ball facing inwards, like so. So I'm going to go ahead and get these screwed in, and then I'll show you the completed piece. Alright, so now you can see the 2 front Cyclic servos on our slanted mounts go with the balls facing in towards the main shaft, and then our elevator servo in the back has the ball even with the main shaft. Now, you can do a couple of other things while you're at this step that I'm going to take a minute to do. So while it's really easy to access all of the servo wires and it's really obvious which wire goes to which servo, I'm going to go ahead and label the servo connectors with a silver Sharpie so I know which servo ports to plug the leads into. So you can see on this servo connector here, I just have 3 little dots because this is servo number 3 in the Spirit FBL. So use a silver Sharpie, make some little marks. Makes it really easy once you've wired up the helicopter and everything's in bundles to know which servo goes into which connector. All right, now, lastly, on page 6, I left out a step that I wanted to just kind of keep it out of the way to make the servo mounting a little more clear. But we're going to take this piece, which is called the pulley bracket assembly, and it already has a bearing Loctited inside it, and it's just an additional support for the secondary shaft here. And so we're going to have to take our motor belt and put it over here and get that back underneath, because once we put this on, we're not going to be able to get it on anymore. And so this piece simply fits onto these 2 holes on either side of the main shaft, and then the bearing will capture the shaft above our main pulley here. So we're just sort of press that down, and it just fits right over the bearing. And then there are 2 M2.5 screws. Get some Loctite on, and then this will bolt into the drivetrain. So a little bit of Loctite, and then tighten through the bracket. And then this is just stiffening up the whole assembly, basically capturing the top of that secondary shaft and supporting it. And now that I have both screws in place, I'm going to go ahead and tighten those down. Again, just a 2.5mm bolt, don't go crazy. And you can see now I've captured the top of the shaft. This motor pulley is now firmly in place and trapped into the drivetrain. So we're sort of still building off of this assembly here, adding more and more pieces and parts as we go. And speaking of which, let's see what's next. All right, looks like we get to take, and this is a part I'm really excited about, our molded side frames, which is unique to the 590. The previous raw 580 that this is the evolution of had a very different design and style, and they have completely molded these sides, and we'll look at these in detail in a second here. But what we're doing in this step is we're adding our battery lock assembly. We're grabbing some of these lock nut, sort of captured lock nuts, and getting those mounted into these in order to prep these to be added to our main drivetrain assembly. We're also putting these canopy attachments towards the back of these side frames as well. Now, one of the things that SAB calls out here is the top edges here that they've sort of highlighted in red are areas where your wiring for servos or ESC, etc. Might be passing around this edge, and they suggest that you take some sandpaper and just round all of these edges. Again, this is a carbon plate, so do this outside in a well-ventilated area with a mask on because you don't want to breathe carbon dust. It's quite toxic. I will say that the edges of my frames came from the factory quite smooth, but I will spend just a second just zipping a piece of sandpaper over the top. And especially when I run my wires, I'll make sure everything is really smooth anywhere a wire may come in contact with. So that's all they mean by that step. Let's come over to the bench and let's start bolting some stuff onto here. So look at this. This is a thing of beauty. Beautifully molded. The carbon work is lovely. These nice sort of ridges and air vents. It's just a really pretty gloss carbon. They've also done what looks like a clear coat over the top of this whole piece, which holds this decal on. It's sort of permanent part of this frame now. It's not going to peel up. Hopefully that clear coat will protect it from fading in the sun as well. And you know, these are the top edges. They're talking about deburring, but they are quite smooth already, which is fantastic. So great job, SAB there. Now, we're going to grab the left side of the frame. Obviously, that's easy to tell because it's got the decal side. This is the front of the helicopter here. This wider sort of leg here is the back. So this is our left side, and we're going to bolt a few things into here, starting with, this is our battery retention, and it's going to go upright. So the word push is in the upright orientation. And we're going to take it through right here. Sort of see this interesting shaped piece here. This is where this is going to attach. So, and then we're going to flip it upside down, come to the back side. We're looking for the two 3x6s. Here they are. We'll get some Loctite on these. And then we'll go through the back side of the frame into the battery clasp. And if you didn't know already, the 590 is going to have a battery tray that can be loaded from the rear. So if you use the built-in connector in the battery tray, you don't have to take the canopy off to change packs, which is awesome. And this release, you can see when I push on the release, this pin drops back, and that's what allows the battery tray to be removed. All right, and then you can see now our battery mount is captured. All right, next up, these, and if you've been around since the original Raw 580 and Goblin Raw, are these great captured lock nuts. So we screw these into the side frames and it captures a plastic nylon lock nut into the side of the frame. So pay very close attention to the orientation of these. You can see these holes here. So this is going to go through from the back side like this, and then you take these teeny tiny little screws and just put a tiny bit of Loctite on them. And they will go in, and once you tighten them, you can see what it's done is it's captured this lock nut, so you don't have to hold it on the back side. So now it's locked into the frame. So there's going to be two in each of these. So this one's going to drop in just like so. And then lastly, on this left side frame, we're going to grab part of the canopy piece here and a nut and this washer. So it goes, the canopy attachment and the washer will go through this large circle on the back side of the frame. So I like to push it through, and then I take my awl, which is again metal pokey stick, and I dip it in Loctite, and I'm just going to wrap around the threads of the canopy support so that when I spin this nut, it will cover itself in Loctite, and then Loctite itself as I tighten this down. So spinning that by hand, and then we'll just grab a wrench and give it a little twist. Don't need a very big wrench. You can also use a driver. Actually, I always forget. I believe a 4mm driver. Nope. 5mm driver into the back side of the nut here. That will grab the actual canopy post, and then you take a wrench and then onto the nut. Now this is just a carbon frame, so don't go crazy tightening that, but the driver holds this piece in place, and then obviously the wrench just tightens the nuts. So that is our left canopy side of the left frame side, lower frame side rather, prepped. We're going to grab the right side and basically do the opposite. There's no battery latch pin in this side, so really all we're doing are the 2 captive lock nuts and the canopy post on the back. Same process as the other side. I'm going to go ahead and do that and then we'll come back. Okay, we now have the right side frame done, so 2 captive nuts installed this side and then our canopy attachment point on the other side. And that is it for page 8. All right, coming back to the manual, next thing we're going to prep are the battery rails with a couple of spacers in between them, here and here. And then these are the front ESC supports. So we just have to do a little bit of prep, adding this sort of front canopy centering piece and a couple of bolts and washers here. So pretty straightforward step here. You get your 2 battery rails and you're going to get them in the correct orientation, which is, we've got these 2 little cutouts in the top edge. So those are going to be facing opposite each other. You've got these 2 pieces here where the spacer is going to go here and here. So those need to be aligned next to each other. When you spin these this way, you'll see these little bump out pieces will stick out opposite from each other. So when you stand these up, these little bump out channels here will both be facing down. Okay, so pretty straightforward here. We take these metal spacers and they're going to just press fit into the hole on each side. And we can kind of get one frame side first. And I'm just going to go ahead and screw the 4 screws in first. Starting with 2, just to capture these so they don't start falling out. Again, this is just plastic, so go careful, don't over tighten these. Okay, and then we're going to press this into the other side. And the screws will kind of suck them in all the way, so don't go feel like you have to push it a ton. And just a random note, as I almost did this earlier in this build, if a screw is giving you any resistance when you start to put it in, stop. You're probably going to cross thread it, which is when the screw isn't aligned correctly. Most of the stuff, and certainly on most kits, certainly on SAB kits, the screw should go in fairly easily until you start to tighten them down. So if you feel resistance, stop. Something's misaligned, something's wrong. So take a minute, pause, and figure out what's going on. All right, so this is set up. You'll see there's a little bit of a curve to these parts. That's intentional. Once they mount in the frame, they sort of straighten it out, but it also helps just capture the battery tray a little better as well. Give it a little preload or resistance there. So we're going to tuck this aside. We're going to grab our 2 front ESC support pieces. All right guys, what's up? Just jumping in here for a minute. Don't be alarmed by the completed model here on its side. I just got to show you a correction for a step you're about to watch. So we learned at IRCHA in talking to SAB, we actually had a part the round way. We had a very early manual I was going on here, so I just missed the direction in the line drawing. But take a look here. So as you're about to mount this ESC support plate to the main side frame here, notice that this inset here should slope down towards where the motor will be. So this slopes down towards the inside of the frame. On the build, I actually have it raising up here, which also looks really cool and also works, but it's not the intended direction. So this way helps draw a little air over the motor and keep it cool in flight. All right, back to the build. Let's start with this guy, which is the one they show in the top of the manual. And then we're going to grab, this is called the front canopy centering piece, and it's going to bolt into these 2 holes here and here, pretty straightforward, with 2 self-tapping screws, each with a washer, and those are a 2mm driver. Nope, 1.5mm driver. So no need for Loctite. You're going to come through from the backside, so you can see there's like a dimensioned sort of ridge outwards here. So this piece is going to go on the same side, and it's going to go with the 2 holes in this piece, obviously facing down towards the screw, like so. So we get our screw, and I'm just going to start one and leave this kind of flopping around so we can get it aligned in the second one. And this is just what looks like a 3D printed part, perhaps. Made to help the canopy align around the front of the frame. And there it is, that simple. I'm gonna go ahead and do the other one. You know what? I forgot the washer. Too busy talking. Let's try that again. Washer. There it is from the backside of the washer. I'm gonna go ahead and pull this one out, put the washer on it. See, I don't edit this stuff out of build videos. Just shows I'm human. We all make mistakes, but no big deal. Back it out, fix it, put it back together. There's a good chance, although there are a few extra parts in these kits, in the bags, in case you lose something or need something. For the most part, the stuff in the first bag, not the extras bags, you'll use all of it in every step. So if you see something sitting there and wonder why it's there, there's a good reason for that. You probably have, in fact, forgotten to put something somewhere. So take a minute, pause, look at the manual, see what you missed, and figure it out. That said, there are moments, sometimes, say with servos, you might get two different lengths of screws for a step. But they'll usually call that out in the manual when that's the case. Okay, there are two ESC support pieces with the extra piece mounted in. There's always one step in a helicopter where there's a whole lot of screws going through a frame side into another assembly. So there's a lot going on in this step, but if you take it piece by piece and go slow, it's not that intimidating. So what you can see we're doing here is we're taking our prepped frame sides that we've been working on, and we are linking them to the battery rails, which is what you see here, and then also to the ESC support tray, which is what you see here. Those front pieces we just put the 3D printed parts on. So pay very close attention to all of the places the screws have to go through. For example, this screw is going through the ESC support tray, also through a portion of the frame side, and then these top pieces here are going through the top of the frame sides and then into our main drivetrain assembly. And SAB does a nice job with these dashed lines showing you where everything goes. By the way, every time I do one of these build videos, somebody asks about this. This is called the silicone build mat. You can find tons of variations of them on Amazon or other sites online. Any electrics, parts, circuit board, supply store, that kind of place has got tons of them. So you can find all that stuff there. Okay, so we've got all of our hardware here. Let's just take our time and go through. Let's start with our ESC support tray. So looking at the manual, it is a 3 by 10 millimeter bolt through a finishing washer into a nylon lock nut, which means no Loctite, because Loctite eats plastic. So take our 3 millimeter here, it's going to go through our ESC support tray, and that is going to go into, do this so you can see here, our upper captured lock nut. And just kind of starting that, and I'm going to grab another 3 by 10. Again, no Loctite, but going through a finishing washer, which is just this sort of raised ridge washer. Which are purely functional as well as decorative. They look really nice on the model. And then I'm just going to go ahead and tighten these down. Now this adds a lot of rigidity to the model, so don't obviously go crazy. It's just carbon, but definitely get these fairly snug. And then you can see we now have our frame side has gotten just a little bit longer. Okay, so next thing is to incorporate the battery rail. So I'm going to take one of our self-tapping screws and put a finishing washer on it. And often with the battery rails, it's good to start on either the front or back position and figure out where that goes into the frame. I'm going to start in the furthest back because I think that's the easiest one for me to figure out which hole it goes in. So you can see there are a series of holes across the frame here that are all in a line. That's going to be where our battery tray is going to come in, and you can see in the manual as well where they sort of point this out. So I know that our self-tapping screw is going to go through this hole right here. So just underneath, I'm going to put a driver in it and kind of lean it there, and then the battery tray, our furthest rearward position, is going to go in right there. And I'm only going to get this mostly tight, not all the way tight, so I can figure out where else this is going to line up, and it's going to be really obvious really quickly. And you can even see where this recess in the frame is where this extra piece on the plastic battery tray is going to go to. So let's flip this that way. And sure enough, yep, there's going to be another self-tapping screw with a finishing washer at that position. And we're not going to tighten any of these all the way until we get them through, so we're just going to line this up so I see the hole. Get that started. All right, so now we've done this position and this position into the battery rail only. And you can kind of see already where the other two are going to go. And these look like self-tapping and a finishing washer as well in the next one down the line. Now again, we showed you how that battery rail was sort of had some preload in it. It was kind of curved, so you will have to sort of hold this in position as you get this next one. So this one's just above the white label here. Okay, and then the last one, again, finishing washer, self-tapping screw. And this one was kind of hard for me to figure out where it went, but now that I have it here, it's obvious that it goes right here, just behind this 3D printed piece. So we'll get that in position, get that started. And now I can go ahead and tighten all four of these. Again, just plastic, so snug these up. Don't go a lot beyond just snug, because you will just tear the screw right out of the plastic. So, okay, so all we've done so far is attach these two here up front, and then we've done our battery rail with 1, 2, 3, 4 self-tapping screws. I'll show you what that looks like on the back side. There it is here, our battery rail captured inside the frame. Now for the fun part, where we're gonna now incorporate the drivetrain into here. If you have a printed manual, by the way, sometimes it helps to sort of cross off the screws as you do it if you feel yourself getting confused at any point. So now we're gonna orient this. This is the front of the helicopter. This is the front of the helicopter. It's gonna be pretty obvious that this is gonna end up going just like so. You can already tell the motor mount's gonna be somewhere over there. And it looks like 1, 2, 3, 4 3mm screws with finishing washers and Loctite here, which is no surprise here. So a little bit of Loctite through the finishing washer, and then I'm going to get this through the frame side and just start it into. Again, I'm going to keep that loose. We'll get all 4 of these in place. I know you're tired of hearing me say it. You can sing along with me before we tighten them down. And I'm going to do the front and back ones first, because it'll just make the middle ones a little easier. So you can see here's 2, to the next 2 there. Now, I'm actually not going to tighten these down yet, and I'll explain why after we get the other frame side on. So we're just going to leave these 4 loose so that this full frame side has a little bit of movement in it. Make sure none of them are tightened too much, so this whole thing can move a little. Yep. All right, and then we're going to flip this whole assembly over. All right, on the left side, a little bit different. Let's look at the manual. You can see here, battery rail, same thing, 4 self-tapping screws down the line, same positions. The ESC support tray, still 2 bolts into the nylon lug nuts, no difference there. The main difference is on the top rail on the other side, on the right side where we did 4 screws across the top here. On this side, we're only going to do 2, the 2 opposite ends. And we'll leave out the other 2 for now. Those will probably be added in later. My guess is they'll capture something else, perhaps the wiring support tray or something similar on that side of the frame. So we're only going to put 2 of those in for now. All right, let's get to it. Again, no Loctite on the ESC support tray into the nylon lock nuts. Okay, now we have our completed frame side. Let's bring this assembly back over. And we're going to start by doing the battery tray. Okay, so our self-tappers. And don't forget the finishing washer. And again, we're going to start in the most rearward position. And we're also not going to tighten them until we get all 4 in. Starting to get something that's starting to look like the beginnings of a helicopter frame coming together here at this point, which is exciting. It's always nice when it goes from a few sub-assemblies to starting to feel like a helicopter coming together. All right, with our 4th screw going in here, same positions as on the other side. We're going to go ahead and tighten all 4 of these down now. All right, last but not least, our last 2 bolts with Loctite are going to go into our upper drivetrain assembly. Again, we're only going to do the furthest outside positions here. Again, I'm going to leave these loose. I'll tell you why in a second. And I know somebody's going to tell me in the comments that what I'm about to do is not necessary, and they're right to an extent. A lot of this stuff just kind of self-aligns, but a little extra effort always pays off, or certainly doesn't hurt anyway. Okay? All right, now what I have over here is a tempered glass shelf, just like you would put, say, in a bathroom to put whatever on. And what's nice about a tempered glass shelf is it's dead flat and level. It doesn't flex. I'm going to put my completed piece on this dead flat surface on a level workbench. And what that means is when I push the frame sides down flat against the glass and I tighten these 4 top bolts on one side and 2 on the other, I know that these 2 frame sides are at exactly the same height in relation to this drivetrain piece, and it just starts to help square up the frame. I'm going to push down on the whole thing. So both frame sides are making equal contact with the shelf, and then I'm going to go ahead and tighten the frame sides. Okay, let's just spin this around and make it easy on me. Now I'm going to tighten the 4 bolts on the other side while keeping the same downward pressure, keeping the 2 frame sides, the sort of 4 legs here, here, and the 2 on this side, pressing equally down against the glass. Again, not a lot of room for it to wiggle in these holes, so probably not necessary, but it doesn't hurt. All right, look at that. We got ourselves a little frame coming together. And it's only going to get stronger as we bolt more and more things onto it. All right, let's head back to the manual, see what's next. All right, next up we get to build the rotor head. But we're going to start with some sub-assemblies. We're going to take care of the radius arms. That won't take us long. So we'll do the uniball radius arm assembly, the radius arm assembly. We're going to build our main drive links here. Then we're going to take care of our head with our head block with our dampeners, with the 70 Shore dampener, followed by the 90 Shore, followed by the Delrin piece here. You can see how it all goes here. There are some optional setups. We're going to go with the Sport and 3D method here, with the 70 internal and 90 external. The other option for hard 3D is to go as rigid as possible with a 90-90. And you can see here in the cutaway that the lip on the Delrin piece will face towards the blade gripper outside of the head block. From there, I'm just going to look in the next page. We'll then add our radius arms to the head block, as well as our blade grip arms with our blade grip arms we'll add to the blade grip itself, and then we'll load up our thrust bearings and radial bearings, etc. into our blade grips, and then get our rotor head assembled. But long way to go before that, so we're going to head back to this page in the manual, hit the bench, and we'll go through each piece one at a time. So honestly, rotor head assemblies is when these silicone build mats shine, because there's all of these little compartments. So SAB does a really great job of keeping everything sort of compartmentalized in bags. So it makes it really easy to sort of empty each bag into a little square of the build mat, but then have everything out so you can kind of move really quickly through the rotor head build. So we're going to start with the radius arm section down here with this little pile. So these are super simple. You take a bearing, push it in with your fingers. You take a spacer, and here's where the awl comes in handy. Take the awl through here, put that spacer through it, take your bearing, and then just follow the awl, push it all together, and then that's that. You can use a press if these were actually difficult to press in, but they just drop right in. So piece of cake. So there's one, we'll tuck that out of the way, and then we'll repeat the process for the other. Super simple. Push the bearing, drop the awl, add the spacer, put the other bearing in, and obviously the bearings go with the smaller diameter towards the inside of the radius arm, so that, of course, now this one doesn't want to push in. Get in there, there it goes. Okay, so here's a completed one. You can see the bearings on either side, and then the spacer is captured in the middle. Okay, those two are done. We're now going to move to the other section of the radius arm, which is this piece here. Similar process here, where we're going to push a bearing in, which is a flange bearing with a spacer in between. The difference is we're going to use a little bit of green Loctite here. So grab a extra bag here. Don't need much, a couple drops of green there. And I'm going to use my awl again. So the green Loctite it's called retaining compound, and it will help hold the bearing into the radius arm. And I'm going to put just a single drop on the awl and then spread it around the inside of the radius arm. That's really all it takes. You don't need a lot here at all. And that's going to hold this bearing in place. So press one side in. I'll take my awl, which I'm just going to clean off first because I don't want to get green Loctite in the rotating part of the bearing. Put the spacer over. So I just put the spacer right over the awl. Take the other flange bearing here. I know this is a little hard to see, and then just hand press the two bearings into the radius arm. Okay, so there's our radius arm. There's another spacer in between these two, the two flange bearings pressed. Tuck that aside and then repeat the process for the other one. So all green Loctite, flip it over, single drop of Loctite. Some people will say it's ridiculous to put green Loctite here, but it does not hurt one bit. And SAB recommends it, so it doesn't hurt. Again, here's the awl, here's the little spacer. Just drops right in. Other flange bearing. Press it down. Get the awl out of the way. Make sure those are pressed firmly. Tuck it aside. Okay, see that? We just banged out two sub-assemblies. Oh, now they want us to build the links. I don't like building links. We're going to do that last. We're going to put that off. And now we're going to move to the head block. So here's our head block. It's just like the picture. Here is our feathering spindle, which is what everything is going to rotate around. Just feel this in your fingers. Make sure you don't feel any burrs. You shouldn't. These are really well machined, but if there are, you can chuck it in a drill, take some really high grit sandpaper or polishing cloth or something, and just make sure that this is nice and smooth. But this one is in great shape. So we're going to take some grease. You need any silicone-based food grade grease is fine. This is one made by Haynes. The Triflow synthetic lubricant works great as well. So I'm going to put some on my thumb, my finger, not my thumb. You think I'd know which finger is which. And I'm just going to lightly coat the inside of the head block with it. This just makes the dampening slide in a little easier. But you don't want so much that it's going to get all over the spindle when you slide it through. So just a thin coating in here. Okay. Take our spindle and I'm going to get the dog hair off it. I have dogs. All right. Wipe any grease that got on there off. Okay, we want to keep the grease out. Okay, now I kept my SAB bags are right here so I know which shore is which. So again, the 70 goes into the middle, which is one of these on this side, and a 70 on the other side. So head blocks here, that's a 70, that's a 70. I'm going to slide these a little closer to the head block, and then I'm going to grab the 90, and which you can actually feel the difference in hardness in them. Grab the 90, slide it a little closer. So now I've got a 70 and a 90. I'm actually going to pop these out just a little further so I can get to them. And the reason I do this is because I'm going to grease these now, just with just a little, but I don't want grease to get in the ends here because that can inhibit the screw that holds our blade grip onto the feathering spindle from the Loctite working. So I'm going real thin coat of grease here. You don't need a lot. Just going to keep things moving so the dampeners can do their job. And I'm just going to coat both of these as well. Wipe the grease off my fingers. Now I'm going to take the two Delrin pieces, which is the hard plastic piece. There's a little lip with a narrower diameter on it. That's going to face outwards. So I'm going to take that and get it pushed over. Same thing on the other side. Okay, so now I've got Delrin, 90 shore, 70 shore, 70 shore, 90 shore, Delrin, in that order. And I'm going to push all of these things into the head block. And the grease is going to help a lot to get these things in here. It's always a little awkward. Sometimes you got to sort of press it this way. You can also sort of push. Don't use your fingernail, use your fingertip, because the nail you can put a ding in the dampener and that makes it not, it cuts it, so that's not good, obviously. There we go, that's pushed in all the way, and you'll see the Delrin piece slots all the way into the blade grip when you get it right, which I can now handily push everything down. Again, using my fingertip, not my fingernail. Don't use a driver unless it's a really big one with a really big tip, so you're not pushing in such a small way. And then there's the Delrin in, there we go. Now I can even this back up, and you can see now there's not a lot of the Delrin sticking out on either side. I'm going to take a rag and get all this extra grease off of everything, including my fingers and the head block, so it makes everything easier to hold. And you don't have to be perfect, but loosely get the feathering spindles sticking out an equal amount-ish on either side. Okay, great. Again, make sure you didn't get any grease inside the feathering spindle. And that is our head block now good to go. All right, next page of the manual, in the upper left-hand corner, they show adding the follower arms next. We're going to do that after we get the blade grips on, because I just think they're in the way otherwise. So we're going to take our blade grip arms, and you'll notice in the blade grip already are installed the 2 radial bearings. So the one on the outside is installed and the one on the inside is installed. So don't go looking for those to add them. Those are firmly installed in the blade grip. So you'll actually need heat. You have to heat up the outside of the blade grip to get these out, because there's some retaining compound on here. But all right, we're going to take our blade grip arms, which are 27 millimeters in the case of the 590. And we are going to find the 2 balls and screws that hold these in. And we're going to go to another color of of Loctite. I'm going to use some red Loctite here, because red Loctite is more of a permanent bond, although you can heat things up to get it to release. But I use red Loctite in things that I know I will never have to take apart. In this case, these balls into the blade grip arm, when you get a new blade grip arm, it comes with the ball. So for me, I want to bond these permanently once and never think about it again. So I'm going to use this red Loctite here on the end of the ball, and then screw that into the blade grip arm. There's one, because this is super, super important it not come out in flight, because that would be bad. And if you accidentally put too much Loctite on, like I just did, no big deal. Screw it in, take a rag, and get that off. Okay, now when we go to we got all kinds of red, green, and blue Loctite going now. When you get to the blade grip arm bolts, we're going to go back to blue Loctite, because that is a part that is routinely replaced in a crash, because they're designed to give and bend a little bit. So there's a good chance if you have a bad crash that you'll have to replace this bolt. Attach to this hole in the blade grip. So you'll go into here, and then kind of self-align. You'll sort of set it in there, and then tighten the screw. And these you want to get good and tight. Okay, great, that's that one. Repeat the same for the other blade grip arm. Okay, so we now have 2 blade grip arms with the balls on the end. So these are ready to move to the next step, which is stacking our washers. And I'm going to go ahead and get everything laid out in a way that makes it easy to explain to you how this works. All right, I have everything laid out now in a way that it makes it easy to explain. So in the 590, nothing goes between the head block and the blade grip. So the blade grips will go right up against here. Inside the blade grip will go, there is a radial bearing that's already installed in the blade grip, followed by a second radial bearing that's already installed in the blade grip. Then this brass spacer here, and then the large inside diameter thrust bearing washer, followed by the main cage of our thrust bearing, followed by the narrow or smaller inside diameter thrust bearing, followed by a washer, and then our spindle bolt. Now, how do you know which is the narrow and the wide inside diameter? You put it over the spindle. This is the wide. See how much that rocks back and forth? That's how I know it's the wide one. I'm going to show you the narrow one. if I rock this one, it rocks much less. That's how I know it's narrow. Now, it's really important you don't just take one and go, oh hey, this is obviously the narrow, so the other one must be the wide. Check them all, because sometimes manufacturers make a mistake and they accidentally give you, 3 narrows and 1 wide or whatnot. Just check them all, make sure they're good to go. Everything here is laid out and ready to go. So let me show you how this works. So we'll take a driver, any driver, doesn't matter the size, and we're going to start greasing and stacking the washers. So I'm going to put a little grease on my finger, and then I'm going to grease the inside of this thrust bearing. Place that on my driver. Then I'm going to take a lot of grease and pack the inside of the cage, it's called, of the bearing with grease. I want to make sure that every recess in this thing is packed with grease. Now, there are a bunch of different thinking as to whether the cage faces in or out. SAB's manual says that the recess in the cage that we just packed full of grease goes in, so that's what I'm going to do. Some people will tell you it should go one way or the other for one reason or another. They're all right, it all works, it doesn't really matter. That's what I'm going to tell you. That's the simple version, and you can fight me on it. So, and then lastly, not greased goes the spacer. So I have these all stacked up on a driver now, and I'm going to take that driver and slide it into the blade grip, and then slide all of the washers down. And I'm actually going to switch to a bigger driver here so I can kind of use it to pack the bearings down. So I'm kind of using this plastic part here to help sort of push. Okay, that's into the blade grip. You'll notice I didn't put this washer on there. I could have, but I'm just trying to keep it out of the grease. And now I'm going to take this spindle bolt, which I'm guessing is a 4mm driver. Yep. And we're going to put a ton of Loctite on here, but then we're going to take most of it off. So I'm going to make sure every inch of these threads is filled with Loctite. And then I'm going to use my finger and push that Loctite into all the threads, the whole length, and then drag all that excess off. Because what I don't want is a bunch of extra Loctite to spooge out all over the place and get in the bearings and gum up the head. So taking all the excess Loctite off, I'll now put the washer on. Then I'm going to put this down for a second. We're going to take our blade grip, make sure the SAB logo is facing up, because that is what's going to go upright. Gently slide it over. And then we'll take our spindle bolt, being careful not to get that Loctite anywhere. And just for now, loosely tighten this bolt with our 4mm driver until it just kind of snugs. You'll notice now it just starts rotating the entire spindle. So take that, we're going to repeat the process on the same side, followed by filling up that cage with lots and lots of grease as best you can. Get every single recess. Stack it all in there. Get the back side a little. We're going to go cage in like we did on the other side. We're going to grease the other side there, and then we're going to take our spacer last of all. Okay, try and get some grease off your fingers. Through the blade grip again. Get our whole stack off. Make sure you get that last part of all of the bearings in there. Pushing that down and into our piece. Just using this plastic part of the driver to make sure it's seated all the way. Okay, that's ready to go. Now, again, making sure I get all the grease off my fingers before I start touching stuff. You can clean your driver off as well. Take our 4mm. We're going to load up this bolt with Loctite as well. So same thing. Lots and lots of Loctite every bit of the thread. Spread that Loctite in all of the threads with your fingertip. Drag the excess out. Put the washer on. Take your blade grip, again, SAB logo facing up with the blade grip arms opposite each other. And then we're going to come around with spindle bolt. And just loosely tighten that until it starts to spin freely. Now we grab another 4mm driver, put it in the other side, Now we're going to counter tighten these against each other. And we're not going to go crazy, but, and if you have a lot of grease on your hands, you're going to have to clean them because it'll just make the driver rotate in your hand. Okay. Now some people use T-handles here and really go for a ton of leverage. I'm not a big advocate for that. All right, here's a moment of truth. Now, SAB heads, and they'll tell you in the manual that it's normal to feel a little bit of tension after initial assembly. They call it axial preload. But what all we care about is when we pull this apart and push it back together, there's no play. I don't want to feel the blade going tick, 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 tick in and out as I do this. So I feel zero play. And then we want to feel not a lot of resistance. You can feel some, like a little bit of drag, but you don't want a lot. What you don't want is there being so little resistance that the blade grip falls under its own weight. See how those just stay there? If I lift them up, they stay there. I mean, the grease and all that should kind of hold them. If they're falling under their own weight, something's loose and wrong, but these rotate freely and smoothly, and they feel really good. And you can see how shiny this is because I got grease all over my hands and all over the things. So take a minute, you can spray some alcohol carefully. You don't want it to all get in the nooks and crannies and kill all your lubrication, but we can get that wiped down. And now we're going to go ahead and install our radius arms. That looks great, feels great, rotates smoothly, most of all. And our logos are both on top, so we did it correct. Okay, we're going to put this like this. So we've got our head block sideways like this, which is upright would be this way. We're going to take this piece here with the SAB logo. So it's facing me so I can read the SAB logo upright. And then we're going to take the arm this way. See how it sort of leans to one side? I don't know if you can tell here, but there's an SAB logo here that's going to be on the outside. And this cutout here is going to go towards this radius arm. So I'll lay it out like so, and then we'll go through this piece by piece. Now there's an 18mm bolt and a 15mm bolt. And you got to get the right one in the right spot. So take the bolts, put them in your hand, figure out which one's an 18 and a 15, and then get them next to each other. All right, so there's an 18 and a 15. Really, you just need to know which one's shorter. That's obviously the 15. Gosh, I can't hold this so you can see it. Anyway, you can see 15 and 18. One's shorter than the other. We're going to start with the 18, which is the longer one. And there are these teeny tiny washers. Now, these washers, should you drop them into a carpeted room, you will never, ever, 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 ever find them again. So handle those with great, great caution. So we're going to take this 18mm bolt. It's going to go into this outside portion of the radius arm. It's going to go into the side opposite this little angled cut here. So it looks like this. So that should look like that. Now we're going to take our awl. I'm going to put a little more Loctite on here just to make this easier for me. And because we want to be really careful where we get Loctite and don't get Loctite here, I'm going to put a little drop of blue and put it just on the threads at the end here, because that's really where I need it. And then this piece is going to go into, see how there's a little lip here on the end? This is going to go in. So here's the SAB writing, rotate that away, and this is going to screw into here. Now we can take a driver, and we're going to tighten this, but we're not going to go crazy. We're not going to tighten it a lot. We're basically going to snug it, and then maybe just a little quarter turn. And that's that, okay? So that this rotates freely, but it also doesn't rock back and forth. There's no play here, okay? So that's that part. Now we're going to take the other bolt, which is the 15mm bolt. We're going to go through, so entering from the side that says SAB in white letters, go through, and then that tiny, tiny washer you'll never find again if you drop it, goes over here. Then you're going to take some Loctite on it all. Same thing, put it around just the very tip of the screw. And then this one is going to go into the lower hole of the head block. So this is the lowest. See if you can. It's going to go into this one right here, the low one. on both sides. Be careful the washer does not fall off as you rotate that around. If you get a bunch of Loctite gooped out, I didn't get a lot, but there was just a tiny amount. I'm just going to mop that up because I don't want that going inside there. This bolt is not a pinch bolt for the head, so you can go ahead and tighten that down. Again, I've just snugged this, and now I'm going to give it a quarter turn, and that's it. I'm not going to go crazy. I want to make sure there's no play, so if I like angle it this way, if I feel a little play, I'm going to tighten it a little more, and I did. But it should rotate freely, absolutely freely, like flop around. But there should be no play, and that's great. And it's actually going to go in an orientation similar to that. All right, now we're going to take this whole thing, flip it upside down, or the other way around, and repeat the process on the other side. Same rodeo. So longer bolt, no Loctite. Bolt enters from the side closest to the straight edge here. So bolt that direction. Little Loctite on the end of it. You can also put the Loctite in the recess that the bolt will be going into. Same idea, still works. SAB letters need to be on the upright direction, just like on the other side. And then we'll go ahead and tighten that till it's snug, and then little quarter turn, make sure it still rotates freely. Great. Then the shorter bolt through from the side of the letters. Tiny, teeny, teeny, tiny washer goes next. I think there might be another extra one of these, by the way, in the extras bag. SAB is awesome. They give you a bag full of extra parts and pieces, and they know from years of making kits which stuff people drop more than anything else. And they put just a little bit of extras in the bag there. A little bit of extra Loctite there, just getting that out of the way. Same thing, lettering is going to face the same direction as the lettering on the head block, which is upright when the head's on there. And we're going to tighten this such that we have no play in the up and down direction, and it still rotates freely. Great, perfect. And those will look like that when they're done. And sadly now, we have to build the link because we blew it off, and now we got to come back and pay the piper. But SAB makes this a little bit easier. First of all, they put a little hole in the link, which conveniently fits on the awl and helps hold it in position. And they also give you this really nice 3D printed link building tool. So if you look at the link, one of these is reverse threaded. So if you try and screw it on and it's not screwing on, start screwing it the opposite direction, because these are reverse threaded. And we're trying to get an overall width here of 62 millimeters. Both of these will be facing the same direction. So just to say, there is, see this little hole here? I was looking for my awl, but I'm using it. There's a little hole in the side of the link, and there's not on this side, so you'll want the two halves of the link to be the same. So since that side was regular thread and screwed in the normal way, I know this one's going to be backwards, so it's going to screw in the opposite direction. And then again, take our link tool, and I'm just getting this ballparked, and then I'm going to set it to face the same way as the other one, which it does. Now, if you don't have a digital caliper, pick up one of these for cheap from Amazon or somewhere. So, and I'm going to set this to 62 millimeters, as close to exactly as I can. All right, I got 62.03, close enough. What's important is that they're the same length, and these are still too long, so I know I have to shrink this some more. And then this just becomes a trial and error process of continually screwing these closer or further apart, depending on what your measurement's doing, to get them as close to 62 millimeters as you can from end to end. Ooh, that's pretty good. Yeah, that's pretty good, pretty on there. So that's 62 millimeters there. Both are facing the same way up. Let's grab that one. And then we'll repeat the process for the other side. Good news is you can kind of look at the other side now, and you know how much thread should be showing or not showing, and can get it put together pretty quickly. I know you might be tempted to use a drill or some way to speed up this rotation. Don't. If you speed up the rotation of the plastic link onto the metal any more than you can do by hand already, what happens is you'll actually start to melt the plastic as it rotates. You can actually feel the heat just from sort of hand spinning these. And that's bad because it means that the threads don't form in the plastic that help give this traction, and you can actually have a link come off in flight, which is bad. All right, that's 2 equal links. Next page, swash plate. Real straightforward here. Basically, take all the balls, screw them into the swash plate, make sure there's Loctite on all of them. And then we're going to go ahead and install our rotor head onto our main shaft. And we're going to install a couple of pinch bolts into the head block, as well as what is affectionately known as the Jesus bolt through the head block into the main shaft with a nylon lock nut. And then on the next page, we're going to go ahead and build our 3 links to 53 millimeters and also install our anti-rotation guide. And that will get the head bolted to our subframe. It's always a good idea when you have a swash plate to check all of the things they tell you are pre-assembled at the factory. So I'm just going to check all of these screws that are here and make sure, even these little guys on the bottom, that these are all Loctated properly. Again, the way I do this is I try and unscrew them, and I don't use a ton of force because I don't want to break the Loctite, but if there's no Loctite, they'll come out effortlessly. And this is all good to go. All the screws I can find are good. So now we're just got to get the swash balls. You can red lock these as well if you want. Nothing wrong with that, because if you trash your swash, you're pretty much putting new balls on it anyway. It is a good idea to check the manual and make sure all of the balls are the same. In some kits, some balls in some locations are different than the others. In this case, in the SAB manual, it's all the exact same part number all the way around, so you know it's the same ball. The only difference is this pin right here on the swash plate is going to get the anti-rotation pin, this guy right here. So, pretty straightforward process here. A little bit of red Loctite around the end of the ball. Screw the ball into the spot. If you get any extra Loctite, like I just did there around the base, just wipe it away with a rag. All right, I'm going to go ahead and screw all these in, and then we will come back. Okay, with that, we've got all of the balls installed in the swash plate. Again, this middle pin of the 3 here, it gets the anti-rotation pin. Incidentally, a 1.5 millimeter driver will fit right in the end there, so you can tighten these. I did wipe all of these with a rag afterwards to get any Loctite that's splooged out at the base. I used red Loctite. And all of these except for the anti-rotation pin, you often have to take the anti-rotation pin out to remove the swash for service or replacement. So I use blue Loctite here to make this easier to get out. But with that, our swash plate is now fully complete, and we have to build the links. Now I know you're thinking, wait, you don't have to build them next, you're supposed to mount the head onto the helicopter. Well, that's the rewarding part, so I'm going to save that till I've earned it, which is after I've built the links. Here is our anti-rotation guide. We'll do that after we mount the swash plate. Digital caliper, we're going to set it to 53 millimeter. Again, if it's 53.1, 0.2, whatever, it doesn't really matter. The point is that they're all exactly the same length. That is the most crucial part here, but getting them as close to what the manufacturer has intended is ideal. But what you may not know is that the location of a servo spline actually has some degree of variability to it between manufacturers. So no matter what you do, there's no guarantee that everything's going to end up at the exact same height the manufacturer wanted it to. So don't go crazy about 0.1 of a millimeter. All right, same rodeo, 53 millimeters. In this case, the links will also go facing the same direction, so they'll both be flat to each other. Sometimes one is at 90 degrees to each other, and there will not be a lot of space between the link and the sort of center portion here. So we'll get these to 53 millimeters each. I'll come back when I've built all 3. It's time to put the rotor head on. It's really important you get the radius arms going the correct direction, because if you don't get them horizontal like this with the 2 radius arms sticking straight out, you won't be able to get them that way once they're over the main shaft. So we're going to look at our head block and see which side is the side that'll capture the nut, which has some flat spots on it, and which is the side the bolt will go through. And we're going to take this hole through. You'll see there's a hole here, and then there's one with more of sort of flat spots here. This is the side the nut will go on, and I'm going to do it so the bolt side is facing me, and there is a hole in the top of the shaft here that we need to line up the hole in the head block with. So we'll pop this over, and do make sure it drops all the way down. You don't want to accidentally put the Jesus bolt above the main shaft, because then your rotor head is not captured and it goes flying off. That's bad. But if you're in the hobby long enough, you will see somebody do it. Hopefully it's not you. You'll see somebody else do it, and then you get to laugh after everyone's safe and not hurt. It's also dangerous. Okay, so see how these radius arms are like this? That's good. If you screw that up like I did a minute ago because I was talking, you won't be able to flip them back because the main shaft's in the way. So make sure these are in the correct orientation. All right, now we're going to take the pinch bolts, put some Loctite on these, and then they go in. There's a recess in the head block. That's pretty obvious where these go in. I'm just going to screw the first one in until I feel the first bit of resistance, and then I'm going to stop. Grab a little Loctite. Screw the second one in until I feel the first moment of resistance. Now the goal, and why we haven't tightened the Jesus bolt yet, is we want to get this rotor head as square as possible to the main shaft. This needs to be a perfect 90 degrees. And the pinch bolts are going to do most of that work for us. So we screw until we feel the resistance and stop, and now I'm going to do a quarter turn. Spin it around, quarter turn, spin it around. I'm going to keep doing this until both bolts are tight, quarter turn at a time, because we're trying to get these as equally tight as possible. Now this is only a 2.5 millimeter bolt. These are not the strongest bolts in the world, so don't go like Thor's hammer crazy on this. Just snug till you start to feel them tighten up, and then stop. Don't go crazy. Okay, great. That's good. Okay, now that you have your pinch bolts tightened, theoretically everything's nice and square. We can come in and tighten our Jesus bolt. You can go fairly tight on this. It's a big beefy bolt into a big beefy lock nut, but you don't have to go crazy. All right, that's done. Now we can take our follower arms, and those are going to go to the flat arms, so the balls that are not at sort of 90 degrees turning sideways. Here, let me go to the overhead here. So these are going to go to the flat portion of our swash. Here is going to go to the follower arms. So if you have a balling tool, it'll make this far more enjoyable and less painful to get these on, but you can sometimes just push them by hand if you have the strength of many men like I do. And if you believe that, but yeah, these fit pretty good. There we go. So those are on now. So as the swash plate goes up and down, those are captured. Let me show you this way. All right, now we're going to drop in our anti-rotation guide around our anti-rotation pin. Pretty straightforward here. So our anti-rotation pin, anti-rotation guide. So you see how these little arms, they're going to sweep in towards the main shaft, so it kind of is hugging that direction. And then 2 bolts through here into this bracket. It does not like to stay put. Make sure you get some Loctite on these 2 bolts, and those go into the holes. Remember that piece that captured the top of the secondary shaft? Well, there's 2 holes on that. We'll get this one in. This feels like it might be Delrin or a plastic of some kind, so we're not going to over tighten these, just kind of snug them up. You don't want to deform the plastic. And this stops the swash plate from rotating. So this part rotates with the head, whereas this part stays with the servos, hence anti-rotation. You can see it from another angle here. So anti-rotation pin, anti-rotation guide, swash plate rotation. This stays. Now all we got to do is grab a balling tool. These unfortunately aren't made. This is the Lynx ball link pliers. Love these if you can find a set on the secondhand market. And we're going to take our 3 matching length links, and we're going to go from servo ball to swash ball. Now on the SAB links, the side with this little cutout piece in it, that's what goes against the servo ball. The side that goes in the outside has no holes in it. It's really important you get these in the correct orientation like that. Because it prevents it's how the ball link is designed to work. So if you get it the wrong way, that's not good, because you will deform the ball link and it can potentially come off in flight, which is obviously less than ideal. And I'm going to rotate this around. You can take a look at this side here as I do the other one, but again, the side with the holes goes against the balls. And that's 2, and then the third one, the elevator one, is always a little fussy. This one you will have to rotate one of the links the opposite direction, because the balls are facing opposite directions. And yes, that will make it a slightly different length from the others, and we'll cross that bridge when we get to it. But again, just make sure that the side with the hole in it is against the ball in both of these. Okay, now we have the elevator linkage. We'll get these servo wires out of the way later. When we do our wiring, we've got our 3 swash links. Now we need to install our 2 equidistant links. These are called the main drive links, and they'll go from the swash plate up to the ball. Now, just like otherwise, these balls are also facing opposite directions, so you'll have to rotate one side of the link to the other direction. Again, make sure the link, the side with the hole in it, goes against the ball. All right, check it out. We have ourselves a pretty significant portion of a helicopter. So we've got our upper and lower side frames, essentially, our main drivetrain assembly. We've got our rotor head, our swash plate, and our cyclic servos installed. So obviously lots to do with the tail, more to fill in the front of the helicopter, but that's a pretty good day's work for me. I'm going to call it a night here, but video-wise, we'll be on to the next step in just 1 second. All right, next up is to install the motor into the helicopter. Ignore this ratio chart here on the left. This is a preliminary manual and they haven't finished this section yet, so we're really just focusing on the assembly here on the right. So it's just a matter of taking the motor mount plate, bolting it down to your motor. Pay attention to the motor wires, make sure those are going opposite the direction of these 2 slots here. And then we're also going to take the motor pulley. The stock pulley is a 20 tooth, and then we'll secure 2 of these set screws, one onto the flat spot on the motor shaft, and then the other one just as a backup. And then we'll go ahead and take the motor and slide it in between the 2 side frames. Now it is a little different in this kit. The motor goes pinion or pulley upright, which is a little different than SAB has done in the past. And interestingly, they give us these springs, which there are 3 separate packets, which I'm going to assume are 3 different tensions of springs. Like I said, this is an early manual, so I'm not entirely sure. And those springs will go between these 2 sort of oval-shaped towers that exist on the main drivetrain portion, and these 2 little stops here on the side of the motor mount, and will help keep tension on the belt. Now there's also a couple of screws and finishing washers that will go in through the side frame into the side of the motor mount as well. And then obviously on top of these 2 set screw posts that we installed earlier, there's going to be 2 nylon lock nuts with washers as well, and those will go on those 2 tall set screw posts, and that will help hold the motor plate securely in place and keep it nice and level. All right, it'll all make sense when you see it visually, so let's come over to the bench for a minute and take our motor mount here. Now, motor-wise, SAB recommends 40-25s in general for the 590 here. I'm going to run an Egodrift 40-30 EC 1050 kV. So I plan on running 6S and 7S setup, so this is kind of the perfect kV in that 1050 mark setup. Big fan of the EC, the Eclipse line of motors from Egodrift, and the 4030, pretty similar in weight to 4025s, if not exactly the same as a lot of 4025s on the market, and just a little bit more power. So big fan of this motor from Egodrift, 4030 EC. If you want gobs of power, you could also run the 4230 at the cost of a little bit more weight, but a lot more power. But for me, 4030 is the sweet spot. All right, so motor, been doing a lot of soldering on the bench. You can see there's still some little chunks of wires and stuff, so I'm going to be very cautious, and I'm going to grab one of the many SAB bags and wrap the motor can in it first before we work with it. So I just take a bag and I just put it over the can of the motor such that I can work with the mount over the top of the bag without issues. So the motor mount with the recesses will go upright, so you'll be looking at the arrows on top that show the direction the motor should rotate. And then you want the wires to come off the side with the short cooling fins. So this plate is just going to drop right here. Do take note of where your motor has its mounting holes and then line up the plate with those. With Egodrift motors, certainly, and I'm sure other brands as well, this is just what I'm familiar with, on a motor 4030 and below, if only 2 out of the 4 holes line up, that is perfectly fine. Egodrift will tell you that 2 is more than enough holes to get lined up. So we're going to take these button head screws and we're going to get some Loctite on them. And with any motor, it is definitely important that you not sink a screw that is too long into the motor, and it'll interfere with the mechanical operation of the motor. So these may look like the screws are very short, but these are actually perfect. They're nice and short so that they won't go too far and get into the moving parts of the motor. All right, we'll take a second bolt here. And again, I don't want Loctite dripping in the motor, so I'm just going to fill the threads of the screw here. And then get this in. Okay, and so I've got both of those aligned. I'm definitely going to give these the business, as they say, so get these good and tight. That is now our motor mount here. Next thing I'm also going to do is these threaded pieces here. I'm going to go ahead and unscrew these, and we're going to get some Loctite on these. Now SAB wanted, green Loctite on here because we're really going for a permanent bond. So why not? Let's grab some green, and we're going to take the pieces here and just going to put my finger underneath and just tighten it until I feel the end of it. I'm going to take a towel, sop up that green Loctite, any extra there. Same thing with the other one, finger underneath, and I'm just going to spin this tight until I feel it start to poke. There it is. Sop up any extra Loctite there. Okay, I'm bending these motor wires straight down so I have as much room as possible to move this thing back and forth. So I'm going to stick these springs into the drivetrain plate side first. So stick them into the holes in those oval-shaped kind of columns, and a lot of the spring goes in there, which is good. Come on, get in there. Not a lot of room for your fingers in here. I guess I could grab some pliers, but there we go. It's got that spring in. Okay, let me see if I can show you that. Okay, so if you can see what I'm doing here, I'm taking the spring and pushing it in the hole in this column. And so both of them now are, here is one and here is the other. And they're going to push against these 2 recesses here. So I'm now going to take this motor mount plate and get these springs to sort of click into those holes. So now you can see there's kind of a spring loaded action piece here. And then we're going to lift this motor plate up, compress it under force, and get these screws started here. There we go, there's one. All right, now those springs are going to stay put. Once you get to this point where you get these 2, just finger tighten. Okay, now I'm going to take the flat spot of the motor and rotate it so it faces towards me. I'm going to take my belt with my pulley on it and take one of the set screws out so I can see through the hole to the flat spot on the motor. And I'm going to put the pulley in the belt. See if I can compress this enough to slide the pinion over the shaft here. Flat spot's still facing me. come on, there it goes, beautiful. All right, so now the tension right now is just being kept by that spring. And just kind of got that flat spot where I want it. I'm going to set the height of my belt that way. And then we're going to take the set screw back onto the flat spot, just barely above the motor plate. Okay. There's that one. I get the driver out, and then I'm going to tighten the secondary set screw. Okay, that's not going anywhere. Okay. I'm going to give this a bunch of spins because I want to make sure that the height of that pinion is not going to walk this motor belt up or down. And man, I tell you, there's not lots of tension. The spring's doing a lot of the work here. Final steps. Those two posts sticking up, get a washer each, because we're going to compress those with these nylon lock nuts. It's going to be a little tricky because ideally that green Loctite would have dried, but I kind of needed to see how this all worked together first. Okay, so because in those all threaded rods there is a driver, so I'm going to use a driver and an open-ended wrench, and I'm going to take these lock nuts and tighten them to the point where the plastic lock nut is fully engaged that shaft. So this is a 7mm open end. It's a nice small one. Shafts, and we're just going to tighten this until that all thread is sticking up through the nylon of the nylon lock. And then once that's the case, I can just throw a driver on this and tighten the whole thing, all thread, all the way down. But I need that nylon to be engaged on the thread. Here, there's a little bit of that thread sticking past the lock nut. So when I use a nut driver to tighten this down, this whole assembly, the all thread and the nut will lower down and tighten this down to the plate. So now it's just a matter of setting the tension. And everything's loose. That spring is doing a lot of the work, but I'm still going to give it a little bit of a pull back on the pulley, and push the plate and make sure I'm getting a lot of tension here. And then I'm going to start with tensioning first bolt on the side. There we go. Then we're going to move to the other one. Okay. Now we're going to check how this belt tension feels. It's okay if you can pinch it a little. If you can pinch it too much, that's not good. You can spin the motor a bunch, make sure that the belt's not walking up or down. So as I rotate this, this belt is not walking up or down. So now I'm going to take a 7mm nut driver and tighten down the lock nuts and the all thread together, thus locking our motor mount in place. So now this motor is not going anywhere. Wow, it's so interesting to see this pinion sticking up. It's kind of messing with my head a little bit. It's just, unusual. But I like it. I love the black case of the Egodrift motor, by the way, kind of disappearing. But I'm sad to not see the Egodrift logo on top looking good. But we all know it's there. All right, next up is our ESC tray, which is a simple matter of 4 bolts into these 2 rails. And then your ESC will attach via your method of choice, either with screws and nuts. I personally am not a fan of hard mounting ESC, so I'm going to use a combination of some double-sided tape and some zip ties so that it can break free in the event of a crash, but you do you. And then we'll connect our ESC leads to our motor leads. So let's head on over to the ESC tray. So 2 rails, doesn't matter which way up these go, they're symmetrical. The ESC tray has a couple of chamfers in the tray, so just make sure we get those lined up over the rails, and then a little bit of Loctite on each of the 4 bolts. And if you've made it this far in the video, let me know what you think the difference between a bolt and a screw is when it comes to helicopters. What do you call them? Are they screws? Are they bolts? Are they both? Is one right? Is one wrong? By the way, if you happen to notice that as I show some wider shots of the helicopter that the tail boom and tail is already built and assembled, it's because due to UPS delaying my motor's arrival, I've been building a little bit out of order. Now I'll edit the video in order of the build in terms of the instructional part, but you may see some stuff bolted on in the video after this point where it hasn't been called for in the manual yet. Don't panic, that's just me building out of order, waiting for my motor to arrive. All right, that is our ESC tray, super simple. All right, next we're going to look at soldering our quick connect battery system. So in order to kind of simulate what's happening in the helicopter, we've got our connection pin would be going kind of that direction. So we're going to get this in there. I'm going to just strip back a little more of the jacket, I think. But I don't want to take too much off because it's just kind of hanging out in the breeze there in the helicopter. And then we're going to get our helping hands in here. And now we're just going to get a whole bunch of solder in that cup. So a bunch on the iron. Basically tinning the wire in the cup, and then I'll just keep adding solder. There we go, beautiful. That's super easy to do it that way. You just come in through the hole in the side and basically tin it in the cup while the helping hands are holding it, and then you're good to go. I'm going to pop this one out again. This is a silicone mat so we can take the heat of these connections, and we will try not to let it touch our skin because that can't take the heat, or the servo wires because obviously that can't take the heat either. And then we'll get our other connector ready, and again we're going to strip just a little more of the jacket off. The Hobbywings come pre-tinned and pre-stripped. Other ESCs may be different, but that's what Hobbywing does. So again, I'm sort of simulating the direction of the wire so I get the twist and all that kind of right. Ugh. Get the helping hand on there. Here we go. Okay. Same song and dance, little solder on the iron. And then let's start filling the cup. Tinning the wire. Everything's getting melted and liquefying and merging together. All right, so let's kind of mock this up. So this will be, the front of the helicopter is here. So this is the front. So I'm negative on this side. The battery tray will be coming in this side. Battery tray is also negative on this side as well. So battery tray is negative here. So negative will be plugging into negative there, positive to there. So that's perfect. So our polarity is correct as well. And we can actually go ahead and tuck these into the connector. These are actually going to end up kind of folding underneath like so and back. It's always hard to sort of flip the image of everything over in your head as to how it'll go. That's right, like so. There we go. So there's our sandwich like that. And we can find two of the 2.5 by 10 millimeter connectors here and get these with some Loctite and sandwich this connector together so I can let go of it. Get these good and snug. There we go. All right, so now you can see this is the ESC side. So in the model, this will go like so, and then this connection, our motor wires would actually tuck underneath the ESC, go under the ESC tray towards the motor. This will sit kind of like so. So from the side, you'd see the ESC. This will go towards the tray. Tray would come underneath and plug in here, and then you can see how the tray plugs in just like so. Now we can verify polarity, so positive here, negative here, negative here, and now we know we're not going to blow it up the first time we plug it in. All right, first screw in these trays is always the fussy one. Once you've got that first one started, the rest kind of self-align. But as always, I would recommend getting all 4 of your screws started before you tighten anything. All right, with all 4 screws in place now, it's just a matter of tightening this up and cleaning up any extra Loctite. So our ESC is going to sit centered on this tray via some zip ties. Our motor wires are going to go underneath and curve back under to the motor. And just make sure they're above the battery tray, and then this power connector is going to fold this way and then bolt in place. But I'm going to just sort of tumble this all out of the way to make bolting this guy in a lot easier. And there are metal inserts in here. You can see the brass here, so you can use Loctite here. So after building some Il Goblin Pros, I can tell you that you don't want to tighten this connector on the quick connect all that much, because the first time you plug the tray in, it will sort of self-align so that the two battery connectors align to each other, because there's some slight variations, you know, with your build and how the tray aligns, etc. So do the quick connect and then tighten the screws while the battery is connected to the tray, and then that will give you a much better shot. And be gentle the first couple of times you plug it in. It gets easier over time. First couple, while everything's stiff and nothing's sort of worn in, can be a little tricky. So if it's not a perfect, amazing fit right out of the gate, don't stress. Loosen the bolts. You can even loosen these two screws that hold this sort of front ESC mount onto the side frames if you need to. Then connect everything, then retighten everything. I don't think you'll have to do that, but in the case of the Il Goblin Pro, it's sometimes helped to kind of loosen everything up. We can take our ESC, and in my case, this is going to go this way. Don't forget to plug in your telemetry cable if you need to, while it's really easy to get to things. Make sure that's seated all the way. Great. And then this guy, in my case, my telemetry cables will come up this way, and my power leads will split the ESC and go on either side like so, and my motor cables are going to tuck underneath. And now before I do this and mount this, I'm going to pull it this way, because my motor cables are going to go underneath. Feel right here on the ESC tray, I should have done this before I put it in, it's a little rough, so I'm going to take some sandpaper under here and smooth out this whole front edge of the ESC tray, and I might even put a little padding on it as well to make sure that the motor wires don't come into contact with anything sharp. And that's much better. Because FYI, if your motor cables from the ESC to the motor come into contact with a sharp edge, they will actually short against the carbon frame, and when an electrical current runs through the frame, it touches a lot of components, servos, FBL, etc. And it's pretty common to have your FBL reboot when that happens, which is not good, as you can imagine. Alright, so now we've got that okay. In this situation, I often will cut a small piece of soft Velcro, the soft side, and I'll fold it over the edge as well. Or you can glue a piece of like split fuel tubing over, and then we'll just fold it over like that. Okay. Now's a good time to get some zip ties set without the ESC in the way. The trick with these zip ties, by the way, is to use a zip tie not so thick that it won't break in the event of a crash, but strong enough that in regular use it's not going to come undone during 3D flight. So I'm just putting the ESC kind of temporarily in place to see where I'll want my zip ties. And get the zip tie to pop back up the other side, like so. So we'll leave that one sitting there. And this other one, I think I can use the sort of pre-engineered slots in this ESC tray for the zip tie. Shouts out to Alex Dean, also of the Rotor Revolution podcast, who uses this tip all the time. Put your blade holder underneath when you don't have a lot of weight in the front, and it'll stop your helicopter from tipping upside down on the bench. Well, not so much upside down, but you know what I mean, rotating. So that's great like that. That looks good. I'm going to put, there's not a lot to put double-sided tape on, but I'm going to put a little here. I don't need much. The zip ties will do all the work. It really just keeps it from moving around. There we go. We got some Velcro square there. Tuck the leads to the side. Make sure your ESC is nice and square. And I will typically capture the power leads in the zip ties as well, as long as I can do it in a way that doesn't pinch them, which I feel pretty good about here. And you can see this has got a little wiggle room here, but it's not going anywhere. This, by the way, is a Hobbywing 150 V5, which for my style of flying is more than enough amps. Some of you who fly really hard or with 600mm blades might want to go with a 180, 160 amp, depending on your brand and what they sell. And then we've got our motor leads here that we're going to tuck underneath. This is going to be super clean. They'll connect through here to our motor, and then we'll get all these zip tied up once that's done. And then obviously we'll manage all our ESC wires. But that is our ESC. You can see the battery connector mount. This is all super clean up front, nice and tidy. And I just need to tuck that power lead down into the zip tie. There we go. And we are in great shape. Now, the only other detail I want to think about while we're right here, and we've just put the ESC on, it's sort of the first time you can take a look at the wiring. We'll have perfect amount of length here to get to the back. We do have this cable tray. Now, in the manual, they have you leave off 2 of the bolts that go into the drivetrain from the upper side frame, and it's because this cable tray is going to bolt, you'll through bolt into there. But I think I actually want this on this side. So I think I'm going to take these 2 bolts out here, move them to the other side, and then put my cable tray actually on this side. I think I'm going to be happier with that. So you can put it on either side, it doesn't matter. There's no functional difference. So I'm going to go ahead and do that. Okay, so now I can take our cable tray and we're going to go ahead and bolt this in on this side. You can access all the wires from the top, so I don't need to wait on anything. Everything's coming up from above. So we'll go ahead and find those 2 bolts and get that in place. All right, for the cable tray, it's a couple of M3 by 12mm bolts. And those are just going to go right through the cable tray, like so. And in. And obviously you're tightening these into what looks to be a 3D printed part, so don't go too ham-fisted on this, or you'll just crack it. There is our wire tray. And like I said, I'm going to run mine down this side of the frame, because like for me, in my helicopter, it just makes sense. All right. All right, next thing to do is flip this thing upside down and make our motor connections and clean that up. So we'll lay the bird this way. Okay, here are my leads from the ESC. Here are the leads from the motor. Now, depending on your radio system, you're going to have to do one of 2 things. First, I like to take heat shrink, and I'm going to slide it down over the motor side of the connection for now. And after I make my connections, especially ones that are hard to get to, I heat shrink over the entire connection to just help hold it in place. In the case of Spirit and Hobbywing working together, I can reverse the direction of the motor from the radio. If you can't do that, you'll need to have access to these motor leads and verify that the motor's spinning the correct direction before you make it sort of unreachable. All right, so now that I have those connections made, I'm going to push this heat shrink up, and I'm going to heat shrink this, and that's just going to protect those motor connections so they won't come undone. And it's just a little insurance, because it sucks if your motor comes disconnected in flight. So okay, now the next thing is I need to play with the wires coming out of the motor and the wires coming out of the ESC and bend them in a way that they will stay, sorry, I know the focus is on the helicopter here, that they will stay out of the way of the battery tray. So that's the next piece to this puzzle to work out. And I can take some of the motor leads back out the front here from the ESC side. Which might be the trick here, is to just take it back out the front. I know I got a little room under the canopy still. And there's our motor connections well out of the way of the battery tray. Try and get these motor connections in the same order wiring wise here. And then the next thing to do is to zip tie them in a way that they stay down and out of the way of our battery tray, which it looks like they're going to do all on their own without being zip tied. But let's check it. We'll insert the battery tray from the back. I'm going to disconnect this battery so it doesn't do anything. And just make sure I'm not hitting the motor wire at all. Okay, one last check now that I have a zip tie around these motor leads. And no impeding the battery connection, so we're in good shape. Incidentally, this will be hard for you to see, but I'll show you. Underneath here, what you'll see, there's my motor leads. There's a zip tie that now goes all the way around the motor leads as well as around the ESC, holding everything to the tray and holding these motor power leads. And then right here, which I know is a little tricky to see, that's my very small pulse 25 farad capacitor backup, and that's under the ESC tray as well. So small capacitor backup here, motor power connections from the ESC, and then there's our battery connection. And that's how I fit it all in. All right, time to look at the tail. So really straightforward tail here on the SAB. So blade grip, we've got our ball that we'll put onto the arm of the tail grip here. Very simple stack goes inside the tail grip. It's nothing but a spacer and a set of thrust bearing. And then the screw into the spindle. The radial bearing here is already part of this tail grip, so we don't have to do that. And then coming over to the head block, this is a nice feature in the 590. So the head block of the tail rotor is actually already single piece machined to the tail shaft, which is fantastic. And this Delrin bushing is already installed when you get your kits into the head block of the tail. So all you have to add is the O-ring and then this brass spacer here. So pretty straightforward. We're also going to take care of the tail pitch slider assembly. Make sure this is theoretically already assembled, but we're going to triple check that. We're going to add what are actually called the tail pitch slider links, but I always call the dog bones. We'll make sure those move really freely. That's really clutch. And we're going to triple check the orientation of these tail pitch slider links with the S on opposite sides here on that. All right, so with that, let's dig into the tail. In familiar fashion, I already have things laid out in the order they go. So you can see here's our tail shaft, got our blade grips, our balls, that's our spacer, our O-rings there. This is our spindle, and then our simple stack of thrust bearings. Again, it is large inside diameter closest to the head block, followed by the main cage of the thrust bearing, and then the smaller inside diameter towards the outside. All right, so we're going to start with the head block first. I'm going to grab some grease, and we're just going to start by sliding the spindle in, and I'm just going to put each of these O-rings on and then apply just a tiny bit of grease to them now that they're on there, because I don't want to risk any grease getting into the end of the spindle here. So I usually try and do them once they're already there. So I'm just going to put a little bit on there, take most of it off with my finger, and then do the same thing on the other side. And then I'm just going to take and push these towards the head block. And I'm going to use the spacers here to help me push these in. So put the brass spacer on each end. Having a little bit of grease will actually help those stay in place. And then we're going to push. I'm only putting my fingernail on the brass spacer. I don't want to risk hurting the O-ring. And I'm just going to press them into the center of the head block, which is a little tricky because it's a very short spindle. And of course everything's nice and slippery now. Don't worry if it doesn't go all the way in. It'll end up going in when you tighten everything together. But that's pretty well most of the way there. So we'll take up what little slack is left, and then we're just going to sort of set the length of this equidistant. Get the grease off my fingers. I'm going to go ahead and get these balls onto the tail blade grips. So a little bit of Loctite on this teeny tiny bolt, and then that's going to go through the tail grip. And then we'll take a 1.5 millimeter driver on the bolt and a 2 millimeter driver on the ball and counter tighten these gently against each other. So we're just going to snug it and then give it just a little bit extra. And that one's good. We'll do the same thing on the other side. Okay, that's our two blade grips together. All right, next we're going to move to our bearing stack. So we're going to start with the outermost, which is our small inside diameter thrust bearing. So do that guy first. Then we're going to load up the cage of the thrust bearing really well. Make sure we get lots of grease on both sides of this. We're going to go cage in again, which is what the manual says as well. Put the other end on, and then put our spacer on. So now we've got our stack of washers on a driver, and we're just going to push it onto our blade grip. Push that down firmly, and then we're going to repeat the exact same process on the other side. So small inside diameter, build a cage, cage in, not to be confused with cage in, that's the spice, and then our spacer. Okay, wipe the grease off your fingers, place it into the other blade grip, push it in all the way, pop your driver out, get the grease off it. Get as much grease off your hands as you can, and then we're going to take our spindle bolts, and we are going to soak these really well in Loctite, and really push that Loctite into the threads of the bolt, and then take a lot of it off. We'll get that ready. Now, again, there's an SAB logo on the top, so put that over the spindle, and then we'll take our bolt, being really careful to just try not to get Loctite against anything. So we'll put half the bolt in, and then I'm going to actually just leave this driver in there to just help me have something to push against. Take the other blade grip in the opposite direction, but also with the logo facing up, away from the tail shaft. Slide that guy on, and we'll take our other spindle bolt, load that up with Loctite. Get that really pushed into all the threads, the whole length of the bolt. Take away the excess, and get that started. Okay, now we're going to take a second 2.5mm driver, and we're going to counter tighten these against each other. So there's one spindle bolt, there's the other. This one wants to be tricky today. There's one. Come on, get in there. There we go. And now counter tighten these against each other. Don't go crazy. And then let's see how we did. These should move very freely, and they do. Again, they shouldn't fall under their own weight. That means something's wrong. You don't have enough tension, but they should be very easy to pivot around. And these will also loosen up a little more with time and flights as well. SAB tails can sometimes be a little stiff on the first couple of flights. I tend not to do too much tail tuning on SAB helicopters for the first 2 or 3 flights, other than maybe some basic gain. And by the 3rd and 4th flight, I can really start dialing the tail in. They feel like, for me anyway, that they bed in a little bit initially. And then again, pull these apart and push them back in. Make sure there's no play. There's not any extra room in there. I don't feel any at all. And with that, this tail rotor is good to go. Next thing we're going to do is move on to the tail pitch slider, which is the piece that will slide up and down the tail shaft and alter the pitch of the tail rotor. So we have these 2 tail pitch links, which have these tiny little plastic inserts that go in them. Again, this is another one of those, if this falls in the carpet, you'll never see it again. And these are simply a press fit, which is a loose press fit into the small side of the dog bone. So just sort of press fit, but you got to keep a hold on them. They will fall out when you pick them up. Now, when you look at the manual, it's really important. So one of these will have an S on it, and you'll probably never be able to see this on camera, but if you can, I'll zoom in here. There's a little S right here on one side, and on this side it's flipped the other way around because you don't see the S. And it's really important we do one side with the S up, and then one side without the S facing down. So we're going to do it just like this orientation. That's the S one, that's the one with the S facing down. Now, we're going to take this, keep the plastic piece inside, and then we're going to insert our bolt. There's no Loctite on here currently. That's intentional. I'll talk to you about that in a second. We're going to go through that little plastic sleeve, and I'm just barely going to start the thread and back it up, and I'm going to take an awl, put a drop of Loctite on there, and put that Loctite right in the hole, kind of work it around so it's in all the threads. Now there's too much on there, that's on purpose. So now I've worked the Loctite in. Now I'm going to tighten the bolt into the Loctite, and I'm going to back it up a little bit, And then I'm not going to tighten this super much at all. I don't want this tight because what I want is this pitch link here should flop freely. If it can fall under its own weight like it's doing here, that's perfect. You want this to move as absolutely freely as possible. If you over tighten this bolt, you will get friction. You don't want that. It's really important you don't get that. One of the biggest causes of tail wag in SAB helicopters is people over tightening this bolt. It's not a common symptom of the helicopter, it's a mistake in the build. Okay, so flipping it back this way, you can see the S, well maybe you can't, but trust me, the S is facing up. So this pitch link here, the S is facing down. So got that in there. Same song and dance here. We'll insert the bolt through the plastic sleeve, which is a little fussy. Again, be really careful, don't drop that little plastic insert. Okay, and then I'm going to wait till I get all the way through this link here. See, I'm a little crooked here, I haven't quite found the thread. There it goes. Okay, so now that I'm in the threads, I'm going to back it up a little bit to expose the threads. Same trick with the awl. Wiggle that Loctite in there. Tighten the thread into the Loctite, back it up, push it in, kind of work that Loctite in. Just snug the bolt up, screw up, whatever you want to call it. And then let's check this one. This one is also equally free. This is your chance now to double check that. You see an S here and nothing here. There's actually some little slivers of plastic kind of hanging out in the middle here, and I'm going to try and just sort of work out of the way. I'm going to very carefully use an X-Acto knife. There's just some burring in the plastic, and it's really important this move really freely, so I'm just going to try and remove those with an X-Acto knife without really cutting at all. I don't want to remove any material, just the burr. Just a little chunk of plastic in there, like a little hair of plastic. Just getting that out of the way. Great, all better. And I didn't cut myself, bonus. Okay, last but not least is this brass insert here is typically reverse threaded. And you want to make sure, now SAB says the factory has assembled this piece, so you want to make sure that that's done and that there's Loctite on it. Really important there's Loctite on this brass piece, so I'm going to take a wrench, tighten it down on the brass piece. I'm going to turn this clockwise because it's reverse thread, and I'm not using a ton of force, but it's clearly got Loctite on it because I'm unable to turn that at all. If there was no Loctite on there, that would have been really easy to back out. So our pitch slider is now good to go. That's the next piece we can add to our tail rotor. So I'm going to take our tail rotor, put both logos facing up like they were. I'm going to take our tail pitch slider and slide it on. I always like to, so it is possible to screw this up. So I always orient things exactly like they are in the manual. So in the manual, it shows the tail rotor going this way. It shows the link with the S facing up on this side right here. So this is my S facing up link. And then they show that going to this blade grip here, and the other one going to this one. So I'm going to get these sort of loosely lined up now. Move my tail pitch slider up just a little. I'm going to grab a set of ball link pliers, and we're going to use that to get the links pushed onto the balls. And those should make a very nice reassuring snap sound. Now, this is really important. Every time you add something to a tail assembly, it's really important that you work the tail back and forth and make sure everything feels free. If you feel like you get to here and it sticks, figure out what's going on, what's wrong, what's binding, what's causing it to stick, what doesn't feel right. The S side, by the way, should be on the outside of the ball. So as I look down here onto the ball, I should see the S, and as I flip this over, I see the S and the ball. So triple check you got that right. If you didn't, your links are backwards and the ball can pop its way out of there, which is not good, as you can imagine. And again, I'm just checking this from all points. As I move things around, does everything feel good? And once this is installed in the helicopter, you can see obviously if you take it too low, it will get stuck, but that'll never happen when it's in the helicopter. Once we have this on the model, we will put a couple drops of Tri-Flow liquid lubricant on this shaft as well to just keep things moving smoothly, but that feels great. All right, now in the next step of the tail, we're going to start to get the tail case prepped. So we're going to take half of the tail case here, and we're going to put our flanged bearing in here. We're going to put our bell crank base in here, and then we're going to slide our tail shaft through that half. We're going to work in our bell crank lever assembly and get this all mounted to half of the tail case and get that all put together. So let's come back to the bench. And we have, make sure you've got the right one of these. There's two in the kit, so you want the one that has the lettering facing this way. It's already got the flange bearing pre-installed at the factory. They did put bearing retainer compound on it because I can't push that out easily. I'm not going to force it. All right, we're going to take our bell crank base, and you'll notice it has a slight little lip that sticks up, and it's really important that that lip faces down when you attach this piece. And this is going to screw into our lower two holes right here with our two bolts with some Loctite. We'll push it through from the other side, get a driver on it, and again, since I'm now upside down, that little lip is going to face up for me. Get that first screw started. Again, don't tighten this all the way, just kind of lightly snug it up so you can line up the other screw, and then once you have both screws lined up, you can send these home. Okay, that's that step done. A little extra Loctite there. Clean up, speaking of which, I should get any grease off of this outside of the tail rotor. Okay, and then next up, the flange bearing is already pre-installed here. So now we're going to take this assembly and we're going to get our bell crank lever here, which this really long bolt is going to work through. But first, let's get the ball installed on here. So we'll take our teeny tiny little screw here, and that's going to go, again, orient this just like you see in the manual. So with the C sort of sticking up in this direction, this bolt will go into the recess and then into the ball. And then we'll tighten the ball onto the arm with two drivers. Don't go crazy, as you know. I'm sure you're all tired of hearing me say all the same things over and over again. And then we're going to take the pins that will actuate our piece. And the manual shows green Loctite for this. I've never felt the need to do that. So I sort of just start them, see how they're like that, and then because I don't want Loctite on the tip of them, and then while the threads are kind of hanging out, I will use my awl to spread some blue Loctite in there. And then I'll tighten them down. And then I'll clean up any excess Loctite with the rag. All right, so now our bell crank has our two pins and it has the ball facing down. This bearing stack has been pre-assembled at the factory. So with our C sticking up like this, we're going to take our bolt through from the same side that the ball sticks through, and we may have to use our awl to sort of align that spacer between the two bearings. We'll just make this bolt go through a little easier. Okay, so now we're through there. And then that is going to stick up. It's going to go through and into our bell crank arm here. And no Loctite on this at all, no need. I'll tell you why in just a second. So we're just going to snug this up. Don't go crazy over tightening this. Make sure this still moves freely. And the reason we don't have to worry about Loctite is we're going to take a nylon lock nut and put this on the top. Now, and it goes right on the threaded portion here. This is sort of like a safety, if you think about it, because really the threads that are inside the bell crank arm are doing most of the work here. But the lock nut just ensures it never ever backs out from vibration. Play my favorite game, because I can never get this right the first try. Yep, see, wrong nut driver. That's the one. And I'm just going to use a nut driver to tighten that nylon lock nut while I just hold the screw in place. And again, I'm just going to snug this up. I'm not going to like give it a whammy. So now you can see the nylon lock nut is in place. The head of the screw is just at the top of the lock nut, and now this thing is never coming off. It's nice and safe. Okay, next up, we're going to add to the mix our tail rotor. So we're going to slide this in here through our flange bearing coming in on the side with the logo. And then this tail pitch arm with the 2 pins we have to kind of work in as we slide past, so that all lines up. And you can see now our tail pitch bell crank, you can see what that does. It changes the pitch actively as that pivots. And while we have this facing this way, we're going to take our 19 tooth tail pulley, and we're going to take it with the set screw orientation facing in towards. And if you look here at the tail case, you see that little milled spot? That is going to receive the set screw that is coming in from here, okay? So we slide this tail pulley on until we see that dark spot through the hole here, as we want to say. And you can kind of see, I don't know if you can see on camera, but you'll see the shiny shaft part through, and then you can see the dark recess there. It's really hard to get this lined up here. So, but first we're going to take the little set screw, and I always use blue Loctite on this. I know some folks like to use red because they feel like it backs out. I've not had that problem. So I soak this thing in Loctite. It is completely drenched. But again, I'm going to work it into the threads and then take all that off, put that on the rack. So now I have a set screw soaked evenly all the way around in Loctite. I'm going to spin the shaft where I can see that spot visibly sticking up. I'm going to line up the pulley with that spot very gingerly, and this will sort of self-align. So if you're off just a tiny bit, it'll find that recess. I don't know if you could see that it just sort of shifted as I tightened. So now I'm going to give this a decent amount of business. Not the business, but meaning I'm going to tighten this, and I don't want this coming out. I'm not going to go crazy, but I'm going to give it a decent amount of force. Now this is just aluminum in here, so if you go too far, you're just going to split the whole thing. But now we have our tail shaft. Obviously this shaft will be captured in a moment once we get the other half of the tail case on. All right, that's it for page 20. Moving on. Okay, coming back to the manual, you can see we're going to add the other half of the tail case here, this tail case spacer, which will set the distance between, and then our tail fin. We're also going to add the tail belt. I can tell you with certainty that I am amazing at leaving the tail belt off. I can't tell you how many helicopters I've built where I forget to capture the tail belt when I bring the 2 halves of a tail case together, or I mount the tail case in the boom. It is amazing how many times I've done it. And it's amazing how many times I've recorded a build video and I'm talking about how I forget about doing it all the time, and then I somehow like get into doing the video and explaining something and I screw it up again. So prepare to be amazed. I never edit it out when I screw it up, so you might get to watch me do it for the 10 billionth time today. You might not. We'll see. All right, first things first, we're going to take our spacer here, and there are 2 holes kind of in the middle of the tail case here. They're a little hard to see, but they are here and here, kind of in between the S's, so here and here. And we're going to get some Loctite on our 3x8. And let's do the one furthest from the tail rotor first. Just kind of get that started. Leave it kind of loose. We'll get the second one on. And this is a little tricky. There's a lot kind of in the way here. It's a little bit off axis, so I'm going to start it by hand. So if you're watching this, I would go ahead and install this right away. There's no reason you can't put it in this early on in this process, because it's a little fussy once you have, it's doable obviously, once you have everything else in. Okay, so now we got this. The next thing we're going to do is we're going to take this spacer, it goes at the back side. We're going to use this chamfered head bolt into this nice chamfered slot here at the back. This is where I keep checking to make sure I haven't done anything that means I can't put the tail belt on yet. Looks like we're still safe for now, but again, I'm legendary for screwing this up. And then we'll put this on. This is probably the last piece we can put on. Okay, get that nice and tight. So now we have this spacer piece here. We've got this bracket here. This is from the underside. That's it from the top side. Next step from here is to install this flanged bearing into this carbon side plate. Now, make sure you get this in the correct orientation. So this here is the top rail here, and this is the bottom rail here. So the easiest way to tell is this slot right here marks the bottom. So this single slot here, that's the bottom of the plate. So we're going to take this flanged bearing, and that is going to go in line with the 3 very obvious holes in the tail case. And then you can see it sticks out the other side. And we're going to take these 3 tiny bolts, get some Loctite on them, and get those going. Don't get any Loctite in the bearing, so be careful where you slap stuff. And I'm just going to finger tighten that for now. So the part of the bearing that sticks up will go on the inside, and then bolts go in from the outside. And the other way you can tell you're putting the bolts in from the right side is this is a flanged recess here. So if the bolt heads are on the same side as the recess, you did something right. Congratulations. All right, that is that. And then from here is where we have to remember the tail belt. I might actually get this right. So the tail belt will loop over the pulley, but go before this spacer. So just like that. And then it goes around this SAB block as well. So just like that. And we're just going to tuck that in. I'm just going to slide it in all the way out of the way. And then this block here will go with the bolt heads on the outside, flange bearing on the inside, and that will tuck in that way. And then we're going to take our chamfered head bolt, and this is what's really going to start to hold this thing together. Get some Loctite on that guy, and then through the recessed hole at the back, line that up with that spacer, and get that guy in there. And you can snug that right down. Great. Again, make sure your tail belt is captured at this point. Don't go any further if it's not. And then lastly, we're going to go ahead and add the tail fin. I love the detail on the tail fin that it's painted. This is not a sticker, so it does not ever peel or fade in the same way that the stickers used to. So good job, SAB. Love that. And just a little bit of Loctite on these bolts that will go through the tail fin. And that tail fin, those 2 bolts are going to go into that spacer, that U-shaped spacer right here with the SAB written on it. So you can line those up. And I also love that there's no paint at the point where the screws go in. So sometimes when you're rotating a screw, it'll chip the paint, but that's not a risk because they left that raw carbon, which is a nice detail, keeps the paint looking clean as you tighten your tail fin. And then we'll tighten these 2 bolts down. And now our tail case is starting to get nice and rigid. It all becomes structural. So the bolts in the tail fin are structural. Last but not least, anytime we start to have a tail case come together, it is important to check it for play. What we do not want, and there'll be shims in the kit we can install here if it's the case, is when I pull on this tail rotor, I don't want to feel anything going tick, 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 tick. I want this tail pulley to be trapped between the 2 frame sides. And there is 0 play. I cannot get that to budge at all. And then conversely, you should also be able to very easily rotate everything. And this is like butter. So easy rotation, easy movement of the tail pitch slider up and down. Feels great. I should be able to do it from any point. I should be able to do it from a blade grip pretty easily. Do it from the pitch arm. And then we're going to take some Tri-Flow Superior lubricant, and I'm just going to put a drop or 2 on the shaft to just put some lubricant on there. So I'm going to put it right sort of on the shaft, and then just work the tail pitch slider back and forth a few times. Great. All right. We have ourselves a tail case with a tail fin. Incidentally, it's a good idea to take some of this lubricant and just put a couple drops just above the swash plate and work the swash plate up and down a few times as well. And then maybe every, it depends who you ask how often you should lube the main and tail shaft on your helicopters. I tend to do it maybe once a month. A lot of guys do it every flying session. Some do it every 5 or 6 flights. Some do it almost every flight. So it depends on where you fall on that spectrum. All right, let's come back to the manual, see what's next. All right, if you've built an Il Goblin Pro, this process will feel very familiar, but essentially there are these nice spacers that become tail boom mounts. and we have to do, there's an inside piece and an outside piece. So the inside piece you can kind of see here, and then this outside piece. And we're going to use some double-sided tape to hold these in place. We'll use some temporary screws to kind of help snug and line everything up, and then we're going to end up removing those, and then these will be the pieces that we will bolt through the mainframe of the helicopter into the tail boom. So we're going to do that on both ends of the tail boom. We'll do it here, then we're going to do it on the back end with these inserts that have some nylon lock nuts captured in them that our main tail case will end up bolting to. We're going to install the support for the tail boom as well, and then we're going to come down and initially install just loosely the tail case into the boom as well. We won't tighten that because that's how you tension the tail boom in this helicopter. All right, so let's come back to the bench. All right, we're going to tuck our tail case out of the way for a second. We're going to grab this oh so beautiful tail boom, and then we're going to start by working on this end of the tail boom. So clear your bench, make sure you're not about to knock everything over. Now you can see this is the double-sided tape pieces. They sort of got a foam double-sided tape. And then we have the outer portion of the spacer here. And then the inner portions have the captive lock nuts. It's probably obvious, but obviously the lock nuts go with the receiving end towards the side of the fuselage. So first things first, in the other bag, most likely I'm guessing, there should be some temporary bolts. Yeah, it's in with the tail boom clamp. So we're going to grab 3 of these bolts, the M3s, and that's what we're going to use to help align everything. As we do it, we're going to use an awl or something, metal pokey stickish as well to help align these pieces. And we're going to go from there. So first things first, let's get our one side of our double-sided tape on each piece. So peel one side of the paper off and then apply it to the flat side of the spacer. And your guide for alignment is just the hole. And I'm going to poke out the hole. So now I should have 3 holes that line up with daylight as I look through the piece. And we're going to go ahead and do that for the other one. If you want, you can poke out the center of the holes before you stick it, but they come out pretty easy. You'll be finding these around your workshop for a while. Okay, and then again, peel off the tape. Doesn't matter which side you peel it off of. Sticky side down to the flat side. Take one of the holes, line it up, and then stick it all down. If I show you there, you can see the orange probably through the hole. Maybe, maybe not. But trust me, that's lined up. And then we're going to do the same thing with the lock nut piece. Pop these holes out so I can see through them to align everything. By the way, you can buy these awls at home improvement centers, but you can buy them in like 6-packs or something on Amazon for pennies. So I have one in all of my toolkits, the one that goes to the field, in my workshop here as well. Same process here. Again, the side with the lock nut sticking out is not the side. The flat side is the side the adhesive section goes on. Just kind of line up one of the holes with the nut and then the other one. And if you just gently push down, you can reposition these if you need to, but once you kind of give it the hard press, it's really hard to move these without damaging the thing. So push lightly at first until you're sure it's lined up and then give it the business. And this is real time. I'm not editing this or speeding it up, so you can see how quick it is. When you're familiar with the process, it goes fast. And I've built a couple of IL Goblin Pros, and I've also swapped booms out once or twice for repairs, so you end up getting pretty quick at this. All right, that is all 4 of our pieces ready. So now we're going to grab an inside set, that's the side with the lock nut, and an outside set, that's the side with the spacer. And here's where it gets extra fun. So on the inside set, we will remove the other side of the double-sided tape. Put that way. On the outside thing, same thing. Take off the other half of the double-sided tape. Here's where it gets exciting. So I'm going to take a bolt and push it through the outside set, and then I'm going to put it in the hole to help line it up. And I'm going to do the same thing on the inside. So this outside one, I just have 2 bolts sitting in here loose. And that's going to give me enough of the positioning I need on this outside piece. Now, I'm going to take out this bolt. So now I only have one in the innermost hole. And I'm going to put a driver in that, 3mm one. And then I'm essentially going to fish this in. This is going to be really hard for you to see on camera. Line it up with the bolt and start to screw it down. There I go, I can feel it bit, and I'm going to do the same thing on the outermost one. So I'm going to skip the middle, go to the outermost one, and start screwing this in to the nut. And I kept it loose, but now that I have it lined up with 2 different bolts here, this one and this one, I'm going to go ahead and tighten it down. And thus it's pulling the double-sided tape from both sections together. And I don't worry about the middle one at all. I'm just using the outermost bolts here to line it up. And it's now pushed this piece into alignment against both screws. And then I'll let it hang out for 30 or so seconds, and I'll just pop the screws out, and then I'm going to repeat the exact same process on the other side of the boom. And you can see this inner piece is now stuck in place with the double-sided tape. All right? Let's do the same thing on the other side. So it seems scary when you do it the first time, because you're like, oh man, I don't want to screw this up. And it's actually really easy when you use the trick with the bolts here. So again, outside piece, 2 bolts dropped in, line up the first bolt, second bolt, send it down. Okay, take out the outside bolt, leaving the innermost bolt, get a driver on it so you can spin it. Take your piece here, use the eyeball to help line it up till it starts to bite. And then get another one in here, do the same thing. And then we'll actually tighten both of these. Let that hang out for 30 or so seconds to grab. I didn't even need the 3rd bolt. And then we shall pop this out. All right, that is one end of our boom, has our inner and outer pieces in it. It'll look like so when you're done. All right, let's move to the other side of our boom. And we're going to do a slightly different version with the 2. This one doesn't have outside pieces because your tail case becomes the outside pieces. And the foam here is a little less sticky. And I forgot to knock out the holes first, which was stupid. No big deal. Okay. So again, flat side of this piece as well. Take your piece, line up the one hole, line up the other, and then press that firmly down. There's one done. This one I'm going to remember to pop out the holes first so I can see through it. Okay. I'm going to remove one layer of the paper. Line up one hole first, and the other. Press firmly, and these don't have to be perfect. The screw will push through a little paper if it has to, but get it as close as you can. Now, and this is tricky because these are really thin and fussy, we're going to remove the double-sided paper. And honestly, if you have an X-Acto knife and you like cutting your fingers, you can use the X-Acto knife, kind of peel a corner up, and then use the sharp tip of the blade to get the paper to come up like that. So now that's leaving the paper sticky side up. Just try and start that with my fingernail first. I'm going to use the X-Acto knife to get it a little better. See how much easier that is with the sharp tip of the knife? Okay, now, same process here. I'm even going to use the same bolts. So we're going to take this piece underneath. This is a little fussier because it's just narrower here, so there's less room for your fingers to move in. So we're going to slide that close. Oh, this is fussy. Kind of use the awl to guide it. So now I've got the awl on the one in the back. There we go. There's the hole. Again, I'm trying to keep it from making contact with the and there's one bolt starting to go. Take the other one. And now I've got both bolts started. I can, and you could use something shorter than a 3x8, as long as it's an M3. You don't need all this thread in here, but it doesn't take that long. And I'm just snugging these up so it pulls the double-sided tape against the inside of the boom. Do not over tighten these. You will hear the carbon crack if you do. And that's all it is. We're just going to pull them snug against the boom, and then we'll remove these bolts. And you can use your finger and kind of push it against the outside of the boom as well. And sorry, I know my hand is probably all up in the way, but now we have our two lock nuts double-sided stuck against the inside. You can probably not see at all. There it is. It's blurry and out of focus, but you get the idea. But that's in there. Okay, we're going to repeat the same thing on the other side. Okay, I already pulled the piece tape off. So this one is even more fun because you've got less room to work with because the other spacer's in there. So same deal, I'm going to use the awl to line up the back hole, sort of. Take a bolt and this driver to kind of line up the other hole. You can also sort of push it away. Like if the tape starts to stick, you can use the driver in the front hole. It feels pretty good. We're going to take the screw in there now. Get that in. That started to grab. Now I can take a screw in the back hole, get that started. Both of those are started now. Oh, we're good. Snug that one up, and then same thing here. I'll snug this one up to pull it against the boom. And then last but not least, we're going to put in the carbon rod support, which is just a little sort of hook-shaped piece. And then we're going to put our tail case, will merge with our tail boom. So give those a push from the inside as well. All right, so now coming over to here, you can see our tail push rod guide here, or the piece the clamp will fit to. Now it's always fun, in the manual they zoom in, so you can't tell, am I supposed to be on this side or that side? It doesn't matter is the truth, because you're approximately halfway through the span of the piece. So I'm going to put this on the side of the tail case, is on this side. So I'm going to put it here. And what matters is you look at the curvature, and let me come back to the manual, it's easier to show you there. Look at the curvature here, and it sort of leans, it's off center on the boom. So the open half of the hook should be here on this taller side of the curve. And no Loctite on these at all, because this is just a small screw going into this plastic piece. So just go through the hole. Now sometimes there's a lot of paint in this hole. That one actually went right through. So sometimes you have to either like spin a drill or just an X-Acto knife in the hole to kind of clear some of the paint out. Be careful, you can hear my driver kind of hitting the boom as I rotate it. I'll spin it this way a little. Just be cautious. The paint's beautiful, you don't want to mess it up. So again, I'm just getting that first one started. Go to the other side. Don't over tighten these. Snug that up. Great, now it's time to mount our tail fin to our boom. So first thing we're going to do is come to the front facing camera here, is do the dance where we want to get the tail belt through the tail boom. Now this boom is pretty big, but I'm going to show you the tip I use for round booms. You want to grab some tape, ideally masking tape, and I'm just going to grab a piece that's about 2 inches long or so. I'm going to take the tail boom, tail belt rather, fold it in half so you get a really narrow piece, and wrap it in tape. And then I usually fold over a little piece of the tape. This just gives me an easy piece to remove it with. And now when I thread it through the boom, it's just going to go all the way through without any trouble at all, because it's really narrow, and gravity itself and a little wiggling is going to take that all the way down. See how easy that was? And the tail boom just popped right out the other side. Now, I'm going to take this. Our caps of our tail case will go on the outside of the boom, and it will be a little snug, but it's not bad. It's just a little bit of a friction fit. See these slots here and here? Those are to give us some adjustment. That's how we'll tension the boom. So you want to make sure those are lined up, and then on the other side as well. And now we're going to take two M3x12s from each side with a finishing washer. No Loctite, because you're going into a nylon lock nut, so you don't need it. And we're not even going to tighten these. All I want to accomplish here is that the bolt is into the nylon lock nut. But I want to be able to freely adjust here. Now, here's another tip. Because it's just double-sided tape holding that piece on the inside in place, don't forget the finishing washers, you don't want to put a lot of pressure when you first start the bolt, right? Like almost none. Just rotate it. It's going to almost self-align. You're going to get into the nylon lock nut. Don't really start to give it a few turns until you know you're in the nylon lock nut, because you can actually push the double-sided tape away from the inside. And it usually happens when you switch to the other side. You've got half done, and then you end up having to take the whole thing apart and re-stick it to the inside, and it's a pain. So when you first put these bolts in, very little pressure. Just let gravity do the work until you feel that lock nut start to grab. Don't risk pushing on it at all. Like, just get it started in the nylon lock nut. Feel that resistance where the screw hits the nylon inside that nut, and then move on to the other one. Because once you have at least one started, it'll kind of hold it in place. There we go. All right, so I got lucky. Smooth sailing there. Again, I'm just going to put a few turns on each, and then I'm going to stop so you can see I can actively slide this back and forth, which is what I want. I'm going to push it all the way in because that's going to make it easiest, because it gives me the most tail belt sticking out the other side to install into the fuselage. So I'm going to go ahead and undo our tape, and there we go. Just like that. And now the obligatory sight down the boom as best you can. Take the twist out of the tail belt, and then move it back and forth and watch the tail rotor spin and feel happy. Okay, all right. That is it for page 22. All right, next, in this raw 590, or Il Goblin Pro 590, sorry, you can see a very interesting way to mount the tail servo. It actually mounts to a plate on top of the tail boom. So we're going to start over here. We're going to take our tail servo, we're going to 90 our servo horn on it, so power it up, set your servo horn at 90, install the ball, make sure you get the screw through the servo horn, and then we're going to mount it to this plate with these tail servo mounts, and then we're going to take that in turn and mount it to the tail boom. This funny looking piece here is just a CAD representation of the tail belt. Don't worry, you're not missing a part. All right, so let's go ahead and get that going. So we're going to take our tail boom and stick it to the side for now. Now, I took the liberty when I had the unit to power up the tail servo to 90 this servo horn ahead of time. I didn't put the screw into it, so I still need to do that. In your servo horn screws, make sure you always put a little Loctite on the screw, because if these come out, you will have a very bad day. And then I'm going to put the ball on the servo horn. So if you look at the manual, they want the ball at the 15 millimeter mark, which on an SAB servo horn is the innermost hole. So we'll find that little screw right here. And again, we're going to put it through the servo horn first on the innermost. Now this servo just has some nylon webbing over it. This is out of another helicopter. Okay, and then I'm going to dip that in Loctite. So I get some Loctite on the head of that bolt. Take the servo ball with a 2 millimeter driver and counter tighten that. Again, don't go crazy. You'll just shatter the servo horn and have to start all over. Okay, so that is our servo upright. Do keep note of which way was upright as you build this. Now, we're going to take these little mounts, and these are keyed. You'll see here that there's like a little piece that sticks up, and then a place where the screw will go, and obviously there's a little chamfer here where the chamfered head bolt will go. So that's going to be on the underside, and then the side that the mount will go is the flat side that has the hole and no chamfer on this side. And then these pieces will simply go with piece in the hole, and then the bolt will go through the chamfered side on the back into it with some Loctite. So find the two chamfered little bolts here. Make sure that the little pin is lined up before you snug those. And there you go, it's going to look like that. So here's the pin in the hole, and then there's our bolt in the chamfered location, and then we'll do the same thing with the other one. And then there's our two pins, and then from the top side there is our servo mount on our carbon plate. Again, this is a full-size tail servo here. So now we can take the servo. We're going to take the spline facing on this side as you see it, and then our servo mount will go in this direction right here. We're going to take our screws in from the back side of the servo. So we're going to lay this flat on the bench like so, and we're going to take our screw, get a little Loctite on it. We're going to go through our servo washer piece and into the mount. And we're just going to loosely get all four of these screws in first. And did I put too long a screw in there? I think I did. Make sure you use the 2.5 by 8 millimeters. I think I might have accidentally grabbed. Nope, that's an 8 millimeter. Never hurts to check. If you use a bolt that's too long, it's obviously going to bottom out, and you don't want that. I always do the top one first because these sort of carbon servo spacer washers, or whatever you want to call them, I like gravity sort of swing them downwards, and then that makes putting in the second screw a lot easier because this plate here is just, by gravity's sake, will swing where I want it to. Alright, so now that I got all four bolts aligned, I can start to tighten the servo down. Just sort of evenly space the servo between the two mounts, and then snug it down. And then when you're done, give it a good wiggle. Make sure there's zero play. It's nice and rigidly mounted in there. Okay, great. So now we have our servo mounted in the plate like so. You can see on the back side perfectly flat. That's why the chamfer's there, because this is the side that's going to mount to the base of our tail boom, which is what we're going to bring in next. So we're left with 4 bolts. This extra one is just for the servo horn, which was kind of them to give us. We've got our 4 finishing washers. Let's bring in the boom, and I'm just taking a look, and it looks like, yeah, you can't really see, but it looks like they have epoxied in 4 nuts in here for us. So that's what these big blobs are. It's just a little piece came up, and you can see the nut is captive in there. Actually, you probably can't, but there's a nut right here that's been glued in by SAB, so that on the other side of these 4 holes are 4 nylon lock nuts. So again, no Loctite on these screws because we're going into plastic. All right, now as you install this assembly onto the boom, this tail servo and its mount, it's important to make sure that the tail servo horn is on the same side as the tail rotor, and that gets it in line with the tail pushrod guide. Otherwise your pushrod will be going kind of across diagonally on the way, and that's obviously no good. So make sure, get it right. And again, I'm just starting all 4 of these bolts. Don't push down too hard. It should pretty effortlessly go into the lock nuts there. Again, no Loctite on these bolts because you're going into nylon lock nuts that have been secured into the boom in the molding process. And get all 4 of these started. If you have trouble with the finishing washer fitting on any of these, just know that you can sort of loosen your servo in the mount, put all 4 of these, send these 4 finishing washers and their screws home, and then retighten the servo. And the finishing washer can kind of sit under the servo. It really will only happen on this back corner one. You may have an issue. I had to loosen the servo and the mount just a little bit and then tighten it, and it fits without issue. SAB knows that a lot of people hate this step, and that it can be a pain to sort of epoxy things together, and they've done all the hard work for you. So really all we're going to do is put some green Loctite on this threaded rod and install it, and that green is going to basically be a permanent adhesion here, and then we're going to screw our plastic ball links onto our threaded rods, and then our tail boom will be ready to go. So we'll be able to test fit this right away, and then we're going to make sure that when our tail servo is at 90 degrees, our bell crank is at 90 degrees as well, and I'll show you how all that works, and that just gets us in a great starting point as we put things together. So, and I love when manufacturers take steps that are not our favorite and make them easier and easier, but check this out. The end is already epoxied on there or adhered in some fashion, and all we have to do is take our threaded rod and stick some green Loctite on it and screw it in. I'm just going to test fit this. Screws in like butter, so that'll be really easy. And we're just going to screw it in all the way till we get to, till it stops basically, which is where this little piece with no thread in the center here is. And then we can screw in our ball link onto the end. So we're going to get some green Loctite out, which is retaining compound. This stuff, you can remove it with heat, but it's still a pain. It's not easy, and I'm not going to go shy. Normally you would not go crazy with this stuff, but we're just going to coat that real well. And then just take it and spin it into the push rod. And then I'm going to wipe away all the excess. My rag here, that's that. This might be the fastest I have ever built a tail push rod. Even faster. I mean, there's some other brands who have done some things to sort of speed this process up, but nothing like this. This is awesome. That I've experienced anyway. I'm not saying nobody's done it, but it's my first time having one show up fully assembled like this. Or at least the ends. Okay, just cleaning that off. All right, so now I have our threaded rod pieces with green Loctite. That's gonna like get really, really rigid in just a little while. And I'm gonna go ahead and get our ends put on, and I'm not going to fuss too much about the length. I'm not going to measure anything right now. SAB does tell you it's approximately 650 millimeters, but I'm just going to rough it in, and then we'll just do it on the boom itself and use that as a guide. So I'm going to call that good on that side. Come around to this side, do the same thing. That is now an end, and you can see I left a gap of about, I don't know, 6 or 7 millimeters on both sides. We'll see how it fits in just a moment. Do you remember how I said I always screw up something in the tail while I'm talking? Well, I'm glad I've held true. I didn't forget to put the tail belt in, but I have the tail case on upside down. So I was not paying attention, and if you look at the writing here, Goblin, tail pin's pointing up. So I've just got to pop these 4 bolts off and flip that around. So I'm going to fix that. So congratulations if you're watching the video. People love to catch my mistakes. I get some messages from folks who are chomping at the bit to tell me I don't edit them out because I want you to understand that, like, hey, everybody makes these mistakes. It's not a big deal. Just fix it and move on. You usually don't catch it till you go to another step and you're like, wait a minute, something's not fitting the way it should. Why is that? In my case, I looked at the tail servo and the bell crank and went, why are they on opposite sides of the boom? Well, here's why. But no big deal. Pop those 4 bolts out. All right, I'm just going to pop this just like that. That's all there is to it. And obviously I got to take the twist out of that tail belt. No big deal. All right, I'll put these 4 bolts in and then we'll continue where we left off. All right, now that we have our servo and our bell crank, the goal now is to install our push rod and set the length of the push rod. So what I want is for this bell crank to be 90 degrees to the boom, and I want the servo horn to be 90 degrees upright from the servo, so this way, and then I want the tail boom length to keep those 2 things in relationship to each other. So I'm just going to, and I just guessed on the length, I just sort of screwed each in a little way, and I'm just going to see how I did, And it looks like I'm a little bit long on here, so I'm going to go ahead and screw these in on both sides a fair amount, placing the ball link kind of just on top of the servo ball. So I'm not actually installing them because that makes it then that much harder to pop it off. I don't want to keep popping it on and off each, because that damages the ball. It just puts wear and tear on them. So I'm going to set my servo horn pretty close to 90 up with just a hairy eyeball. And then I'm going to set my bell crank. And then I'm going to I'm not even going to put it in the pushrod guide yet and see how I did. Looks like I could still go with shortening quite a bit. I'm going to basically bottom this thing out, I think. Feeling really good about this, so I'm going to go ahead and pop it into the pushrod guide. I'm going to triple check I'm putting this on in the correct way. I'm going to use my balling pliers to put it on the tail servo side. So that's that side popped. Now I'm just going to loosely place it on the bell crank, and that's looking real good now. So with my tail servo pushrod at about 90 degrees, you can see this bell crank is pretty darn close to 90 degrees across. It doesn't have to be perfect. The closer it is, the more likely it is you're going to have equal throw. Depending on your flybarless, a lot of flybarless systems like your left end travel endpoints and your right end travel points to be within, say, 10 points of each other. And then the last thing we're going to check is we just want to make sure that you're getting full movement. It's easy. The pushrod moves freely, and then we're good to go. Great. All right, with that, we have a fully complete tail boom, tail pushrod, tail rotor assembly. And I always like it if I can take the tail grip and move it and actually move the servo from the tail grip. I think that's a good thing. Our tail boom's ready. We can start thinking about installing this into our main assembly. Let's go back to the manual. All right, it's time to put the boom into our main section of the mainframe. It's simply a matter of sliding it between the upper mainframes here, and then there's 3 M3 by 18 millimeter bolts with finishing washers, no Loctite because they're going into those nylon lock nuts we installed in the end of the boom earlier. Then we're going to make sure we've put the twist in the tail belt correctly and have it around the tail pulley correctly, such that when we turn the main rotor clockwise, our tail rotor goes counterclockwise. And then we're going to move towards tensioning the belt. And there's a method where we're going to sort of walk some bolts to get the tension we need and make sure the tail's nice and square. But pretty straightforward step here. All right, so let me see how I'm going to show you how this is done. So we're going to take the main section of the helicopter here. I'm going to get all the servo wires out of the way. And then I'm going to take a minute to get the twist out of the tail belt. The twist is you take your tail belt and turn it this direction, such that when this goes clockwise, your tail rotor is going counterclockwise. But we'll continue to check that as we go. And I'm going to push this between the idler pulleys, and then I have to kind of tuck it under and then slide this into the frame. A little fussy, but you'll get there. You can kind of turn the whole thing on its side, and then you can guide the tail boom in, and then I'm also trying to get the tail pulley or tail belt around the tail pulley as well. Get it in between the idlers. So I'm going to turn this upside down, kind of angle the rotor head to help this out a little bit. Now I can see what's going on with the tail belt. I know this is very hard to show you on camera, but I'm just taking my time working the tail belt around the tail pulley, sliding the boom in kind of a little extra so that I have lots of slack on the tail belt. And then I can start to pull it. So now I'm wrapped around the tail pulley. I have my tail belt in between the two idlers. So it's correct, there's no extra twist in it. Now I'm going to flip it back upright. I haven't done a single bolt yet, and I'm just going to take a quick chance to turn this clockwise and make sure my tail rotor turns counterclockwise. And it does. I haven't tensioned anything, I haven't screwed anything in. And then I'm going to lay it on its side and line it up now. So I'm roughed in. So now I got to get the 3 holes to line up with the spacers. Let me see if I can get this so the overhead camera can see it. So that's pretty well lined up. So right now, I'm lined up. If you could see through these holes, you would see those 3 spacers. So now I'm very carefully, I'm going to start with the middle without pushing too much, because I don't want to risk undoing any of that double-sided tape. I just want to capture the lock nut, start to feel that resistance in the middle, and then I'm going to go ahead and grab one of the ends. Get that guy in. Again, not really pushing down at all here, just letting gravity do the work until it starts to bite into the lock nut, which it has. And then same thing over here. I'm not going to tighten this because I feel like I want to make sure the other side's lining up well before I commit to tightening anything. So I'm going to flip this on this side now. Keep mindful of your tail servo wire. And it looks like we are nicely lined up here, which is not a surprise, it should. And then we're going to go ahead and drop in these. Again, gravity's doing the work. There's the nylon lock nut. You can instantly feel the resistance increase when you start getting into the lock nut. Okay, there's one. Go to the other end. I like this part because once you get to the point where you feel like you've got all of the bolts in, here's the last middle one, and they all hit a lock nut. There we go. That everything is good. And you feel like you made some headway. So now I'm going to go ahead and just send all 3 of these. Again, don't over tighten. You know, these are like 3D printed spacers and lock nuts in plastic frames, so you don't want to go crazy. So snug them, give it like an extra quarter turn, and that's all it needs. It doesn't need a lot. Okay, we're going to flip this back over and do the other side. By the way, if you're looking at my build and going, where's the motor? That's an excellent question that you should ask UPS. So I skipped the motor installation step because UPS decided to skip my house. I have a motor on the way for this build that should be here tomorrow. So move to the tail boom. I'll put the motor in tomorrow. And you can change the order of assembly on a lot of things in a helicopter without any issues. So that's why there's no motor in here yet. Okay, with that, we can start thinking about how I'm going to route the tail servo wires. Take this. Now, if you have too much slack on your tail belt, just take your tail case, slide it back just a little bit, and you'll be in great shape. All right. Whoops. Except that my tail belt came off of the tail pulley, and we wrap it back around the tail pulley. That's actually a good trick. If you want a little more slack to get around the tail pulley on this end, flip it off of the tail pulley on the back end, just temporarily. It'll just give you a little more slack. All right, now that I have that lined up, I'm just going to push those back. All right, we're going to double check. Clockwise here is counterclockwise there. I also want to make sure I don't hear anything weird. Just hear gear noise. That's good. I don't hear. What you don't want to hear is if there's a twist in the belt, like inside the boom where the belt is twisted, you'll hear the teeth on opposite sides of the belt rubbing against you. It'll be like tick, 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 this terrible like sound. I'm doing terrible impressions of it, but you'll hear something that sounds terribly wrong and not like this. Like this is spinning right now. And it sounds fairly smooth. Okay, so we're going to set the tension. Now, SAB has a couple of different ways you can set the tension. Let's go to the manual. I'll show you their method. Essentially, the method, and this goes all the way back to the Krakens from SAB that you would use, is you basically tension 1/2 of the tail case and then leave the bolts loose on the other side, and then you push sideways, and then that sort of, and then you tighten the screw. So in this case, these guys here would be tight. You would push this way, which would take this side of the tail case and move it downwards, and then you would tighten the screw, then loosen these screws, and then go this direction. These would be loose, these would be tight. You would push this, it would make this side of the tail case move further away, and then you would tighten that. That's one method to do it. I use a different method. Here's mine. I use gravity. I don't like to run a lot of tail belt tension. I don't think it's necessary, certainly not for the way I fly. So I'm literally going to just loosen all 4 of these bolts, make sure the tail case moves freely, and it does. And I'm going to stand up. You're going to lose my head here, but you'll see the helicopter. And I'm going to hold this thing by the tail case. Sometimes I'll do this with a battery in the helicopter, and that'll get me a little more tension. And I'm just literally letting gravity do its thing. And I can push down on the tail case, but I've just got this thing hanging. And then I'm going to tighten 1 bolt on that side, 1 bolt on the other side. This is a little more effective once you have the weight of a battery in the helicopter. I'm just going to do this here, and I might do it again later. And then I'll tighten the last bolt. So basically the weight of the helicopter is what's pulling the tail belt tension. Some 3D pilots like to run a ton of tail belt tension, and if you do, the method of walking it back. But if I flex this tail belt, it's got just the right amount of tension for me. Again, we all know what we like after the years. It's smooth, it's not going to skip a tooth, and it feels really good. Great. I will show you now the walking method. I'm going to loosen the side away from the camera, so this side. I'm going to keep it up. So now this side is tight, this side is not. I'm going to take the tail case and I'm going to angle it by pulling on it that way, and then I'm going to tighten this. Okay. Now I'm going to reverse the process. I'm now going to loosen this side. Now I'm going to take the tail case and I'm going to pull it the opposite direction. And then I'm going to tighten these down again while I kind of warp it away. And as I'm doing this, I'm like walking it back 1 side at a time. So as I add tension in one way, but now I'm crooked, you can actually see that it's not straight. This is leaning towards this direction. And when I loosen these 2 bolts here, it'll kind of self-straighten again. And there it goes, sort of self-straightened. Push it back again with my hand, and then tighten the bolts. And now it'll be straight and super taut. Yeah, loads of tail belt tension there. More than I like to run. So now the tail case is back to being square. It's not warped at the end. Because as you're pushing one side, the tail case will actually like curve this way until you loosen both and get equal tension. And now I've got loads of tail belt tension, and it feels great. Now I'm going to undo that because that is too much tail belt tension for me, and go back to my hanging method. But what's most important with the walking method is just that you make sure the tail belt, the tail case, because it's 2 separate halves, is square so that they're not curved to one side or the other. Obviously you want the tail shaft to be 90 degrees to the tail boom. All right, we got that. All right, it's fun time. We're about to put the skids on this thing, and you know what that means. Once you have the skids on the helicopter, it means you get to test fit the canopy, which is pretty damn freaking exciting. I love that part. So let's grab the skids and get this thing standing up. Little tip when you're doing the skids, go ahead, get the bag for page 28 out as well. You're going to want to grab the 4 teeny tiny self-tapping screws and take your skids, and these are the screws that will capture the skid so it doesn't slide back and forth, and just start these screws. Don't let them protrude into the hole where the skid pipe will go, but just start them. It's a lot easier to start these screws when the skid is, upright in your hand versus in the helicopter with everything in the way. So get these started. Again, don't tighten them such that they stick through into the hole. Okay, we've got those 4 self-tapping screws started now. Again, those are from the next page. And the other thing we have to do is take the other 4 self-tapping screws from back on page 27 here, and we're going to take our canopy front block and mount it into this front skid. So we'll do that before we put the skid pipes in as well. Then we're also going to have to CA the ends in, which is a step I hate. So again, coming in from the bottom. When you're done, it should look like that. So SAB logo on top of the skid, rake going this way, mouth coming out this way, mouth kind of like because it bites down on the canopy itself. I don't like to, by the way, glue the ends into the skid pipes until the very last thing, because sometimes it can make it harder to slide them into the skids. So I take my skid pipes, slide them into the skids, struts, whatever you want to call them, landing gear. And then we're going to bring the helicopter over and sit it on here. I'm going to make sure this is square and flat sitting on the build mat. I'm going to pop this front set, add this back set back, and these will fit over. Alright, so now we have it kind of just loosely sitting in here so we can get things lined up. There are 4 bolts with finishing washer, no Loctite here because we're going into captive lock nuts in the skid itself. So you'll line up the hole, okay? There's the 2 bolts in this side. And you might have to slide the skid back or forward to get the hole to line up. This is when it gets exciting for me because it starts to look like a helicopter. A lot. A real lot. And honestly, at this point we have motor, ESC, tray, and then battery tray because that involves some soldering because of the quick connect system. So we got to get all that set up and then we're ready for wiring and setup. And slapping some blades on it. Don't mind that creaking noise, it's just kind of the carbon shifting as I tighten the skid bolt here. And it's important you're on a flat surface as you tighten these, by the way, because if you're not, you can actually tighten the skids in with a twist. And we want to avoid that for sure. All right, now I'm going to move this build mat out of the way here. Get ourselves super flat here. I like to center the SAB Heli Division logo between the skids. So you can see on the skid pipe here it says SAB Heli Division, and I set my spacing by just centering that logo between the skid pipes because I think that looks great. You may feel like it sticks a little too much out the front or not enough out the back, but I don't like cutting off the logo by doing that, so I center the logo. You do what you like the look of. The other thing that is a personal touch is the angle of the rake. Some people like their skid tube sticking straight out. I like to rotate mine in just a little. It's all personal preference. It makes absolutely no difference in the air whatsoever. So you get your, and you can land on its side for this part. It's kind of handy to set the spacing on the skid and then the angle of the rake in. So like I said, I'm going to twist mine in a little. I've got my logo centered, and then we're going to take these little tiny self-tapping screws from underneath and tighten those. So one hand's just going to hold the skid and the other one's going to tighten this goofy little self-tapper into the skid pipe. And then you know it's sunk if you can't move the skid. Double check that you like the angle of the skid rake inwards, that your logo is centered, or the text is centered, and then tighten the other one. Okay, and then we're going to do the same thing on the bottom skid. In order to do that in the same way, I'm going to flip it back over the other side so that I can see the logo. And I'm going to eyeball the rake to get it the same. Triple check center on my logo. And then tighten just one of these self-tappers, and then I'm going to just put it upright, make sure the rakes look equal, which they do. And by rake I just mean the angle of that front bend. Okay, now I'm going to pop it on its back, so rotate the head 90 degrees so it sits upright like this, and we're going to glue in these 4 little ends. So the way I like to do this is I start them about halfway in. These are pretty loose fit, which is nice. Dry fit them. This one's a little bit of a friction fit. Yeah, these are all pretty loose, so. Okay, we're going to grab some medium CA. Don't use thin because it'll go everywhere, and that sucks. Okay, and then the goal is to get just a little bit on your fingers. No, the goal is to not get any on your fingers. This one's fine, so it only takes a little, whoops, a little bit. Smear it around with the bottle, try not to get any on your fingers. And then push it in, there's 1. 2. There's always one that doesn't want to go in. Give it a little love tap with a driver handle. And there we go. And if you're anything like me, you now have CA on your fingertips. Try not to glue your fingers together. And then we can take this guy and flip it upright on its skids now. Check it out. Now, if you're building, this is a tip from Alex Dean, who is a fellow member of the Rotor Revolution RC podcast, best helicopter podcast on the planet, but I'm biased. I'm also one of the hosts. But my friend Alex Dean on the show gave me this tip. So you take your blade holder, turn it upside down, put it around the boom while you're building, and now if the helicopter doesn't want to stand up because there's no motor or ESC weight in the front, this will sort of stop it from tipping all the way back, which is great. So we'll do that. It's time to grab the canopy. All right, we're going to jump ahead to page 31 of the manual, only so we can test fit the canopy real quick. And it looks like we're going to put a canopy grommet in here, and then we're just going to slip these canopy knob in here. You can put a very small drop of CA on the grommet, and then insert the quick release canopy mount. This way, these don't fall out. I've never done that, honestly. I've never had a problem with that being a thing. So there's also a couple of self-tappers into this plastic piece on the bottom canopy that just helps it self-align as well. So let's go back to the bench. So, and I know you're saying that we're not at this step, Nick. Why are you doing this now? It's because I'm terribly impatient and I have to test fit the canopy as soon as I have the boom mounted and the skids on the helicopter. So let's get this piece here. So you'll see on the bottom of the canopy here, there's a couple of little holes. And then there is this piece here, this sort of 3D printed piece, and it sits inside the canopy. Screws go on the outside of the canopy and go into this plastic part. So grab your 1.5 millimeter driver, and you're gonna go, and this piece sort of follows the curve of the canopy, which when you're putting it together, it'll make perfect sense, and you'll be like, oh yeah, duh, of course it goes like that. Just trying to get this to grab. There's one, and this just keeps the piece aligned left to right around that sort of canopy. Okay, that's all we have to do to this part. Now we're going to take these grommets, which are these rubber circular pieces, and this is a little fiddly. We're going to get it into the hole here. So you sort of push them in as best you can. Which you can't see any of because you can see it's just, I'm just trying to like mash it in there, and then we'll clean it up on the back side. So you flip it upside down, and then you can kind of see the grommets start to come through on the back side, and you just sort of use your fingernails to work it around and get it sort of cleanly on the front and back side of the canopy. So kind of put your fingernail underneath the grommet to help it split around the, sorry, I know you can't see this at all. It's kind of impossible to get it on my finger in the right spot, but kind of see here, see how it's all manually. I'm just like using my fingernail to get it to cleanly fit over. And it's a bit of a pain. And then once you have it kind of close, you can push this piece through. There you go. That's one side. We'll do the same on the other side. All right, let's test fit this thing. So again, we'll split it around. Just tuck the wires in here for now. Split it around the head. Some of the stuff on the front side will align a little better when the ESC and all that is. Wow, this magnet is strong. Everything's a little stiff to slide initially. There we go. All right. Gotta take this off now because, you know, let's see what this looks like. Look at that. Our 580 is starting to take shape. Awesome. This looks great. All right, so this next step is to mount the flybarless plate, which looks like this piece right here, onto our airframe, where your FBL flight controller, etc. is going to go. Now, SAB has been using these dampened flybarless mounts for some time now as an option, and they often show it as the first choice in the manual. And I'm honestly not a fan of these. I feel like most modern flight controllers, such as Rotor Flight, V-Control Evo, Spirit, W3, W1, and other variants, all of these flight controllers, CGYs, all of the main popular FBLs these days, much prefer a rigid mount. Now, even in ignition models, I think the flybarless have, you know, great filtering such that they're just not affected by that to the way that they used to in the past. So I don't recommend these mounts. I'm not going to show you how to put these in because I think you should use the rigid mount. So that's what I'm going to show you. The manual does a good job of explaining how to use these dampened mounts if you want to. A word of caution, if you use these, they can be a pain in the butt to get out because once you get Loctite on here, this rubber tends to split while you're trying to back it out because it's literally nothing but rubber in between sort of the threaded portion and then the top portion, and the rubber tends to split and then you end up using pliers to get it out, so it's a pain in the butt. So I suggest you just go rigid, but you do what you would like to do. All right, let's look at the manual. I'll show you what I'm talking about. So these here are the dampened mounts with these rubber pieces in here, and then there are some brass ferrules we're going to use as spacers for a rigid approach, but it's just a simple matter of attaching the plate to the FBL support bracket and then bolting that in between the side frames. Let's take a look. All right, so I have the plate and the support. So this is going to go like so. I'm just taking a quick look as to which holes we're going to use. Okay, just like that. So it is the outside set and outside set is where these are going to go. Now, we're going to take, there are a few different sizes of screws. If you're using the dampened mount, you'll use these very short chamfered heads. We're going to use these slightly longer chamfered bolts and some Loctite and these little brass ferrules. Ferrules? I don't know how you say that. Ferrules? Ferrules? Brass spacer. How's that? Grab a driver, get a little bit of Loctite on there. So we're going to try and sort of pre-stage our little brass spacers. And honestly, you could probably just go straight to the plate. I just think having a little more air there can sometimes be helpful. All right, so we'll take the plate, put it on top of the brass, take one of our chamfered screws, get some Loctite on it. So now I'm going through the brass spacer. And again, we're not going to tighten these down until we have all four of these in place. And if the brass isn't quite lined up, you can just take another use for the awl, kind of line it up. All right, now I have all four. I'm just going to go ahead and get these nice and tight. And then just take a rag, clean up all that Loctite that's splooged out everywhere. And there we go. There is our flybarless plate. You can see there's a slight gap thanks to the brass spacers, which could be handy for tucking wire in there if I feel like it. We'll see. I like to keep my options open. And then we're going to go ahead and mount it in the fuselage. Let's see if I can get you a good shot of that. All right, so take the 2.5mm bolts, a little bit of Loctite. These go through a finishing washer and then into the posts of that FBL bracket. It's going to be a little fiddly to get lined up. Once you get the first screw started, it's not so bad. There we go. And then I know, you know at this point, but we'll get all 4 bolts in before we tighten anything. In my case, I want this tail servo wire to be on the back side of this plate. Just give me some flexibility to tuck the wire kind of into the boom and then plug it into the FBL like so. That last screw, and then we'll send them all home and tighten them all down. And it is important that these be nice and snug. You don't want your FBL plate vibrating or bouncing around unnecessarily. And then you can just take the dampen mount and those 4 little screws, stick them in a baggie. If you ever sell the helicopter, it's nice to keep the stuff you don't use, the optional parts, and pass those on to the next owner. So here we go. And with that, there's our FBL plate mounted right here, ready to go. This little piece here is a place you could put a small antenna perhaps on, or just to bundle up the extra cables from the FBL depending on which way you run your wires. All right, next step that I'm going to work on is the battery tray. So this is pretty straightforward. We take the carbon plate, we sandwich our battery straps underneath it, and then we screw this plastic plate in next, and you don't actually have to sandwich these. You'll be able to thread them in after the fact. But we put this plastic plate in with all these self-tapping screws, and then we're going to start building our, this is the connector if you decide to use the quick connect battery system so that you can slide the battery in and it'll plug itself in as you do so, and then you won't have to take the canopy off to make the battery connection. We are going to go ahead and do that on my build. So I'll show you how to do that, and I'm going to make the tray flexible so that I can take the pack off, so there'll be this connection plus an additional battery connection right behind it, so I can plug and play with other batteries and see what I want to go with. All right, let's go to the bench. If you have an electric screwdriver, this is one of the ones from Fantic, which I'm a big fan of. It is nice for this step because there's a lot of these self-tapping screws and it gets boring fast. So the tray does have an up and a down. You can see there's chamfered slots here, and the chamfered slots is the side that will go, in our case, I guess you'd call that the top. So you just line it up with the holes, this plastic part. There's the smooth side, that'll go down. And then we'll just line this up like so. And then we have a million of these self-tapping screws to deal with. I tend to do the opposite corners, because that sort of self-aligns all the others. These have kind of a very blunt nose versus a pointy nose, so they're a pain in the butt to get started. There we go, there's one. Go to the opposite diagonal. Get this guy in. All right, 97 more screws to go. I'll be back when these are all done. All right, when you have it all done, you'll see there's no gap there. Our battery tray is now good to go. Do screw it together on a flat surface. It'll keep everything looking good. Okay, now your battery straps. In my case, I'm going to run a combination of 6, 7, and maybe even 8S batteries on here. So these straps, you'll see the gaps in the tray. We'll go here. This is the front with these 2 noses, so I'm just going to go ahead and put that strap in. And I'll probably only use 2 straps with a pack that size. So I'll find the other gap here. And that should be enough, just like so. Okay, there are our 2 straps. Okay, next thing I'm going to add is some Velcro. Now SAB gives you double-sided tape. And double-sided tape would be fine if you were, picking a battery per tray or running multiple batteries. I'm going to use Velcro and swap out packs. So I'm going to run a strip because I'll be running my 6 to 8S packs towards the front of the tray. So I'm not going to run Velcro all the way down. This is a Pulse 6S 5600, one of the packs I'll try in here, so you can see that would fit in here nicely. And then straps would go something like that. You get the idea. So, but we're not going to strap that in just yet. Now, the way these battery connectors work, let's take a look here. So this is the ESC side connector, and it gets the male bullets in it. And you can see they just get sandwiched in between these 2 halves of the connection. So, and you can always think, just like in your house, the male plug travels towards the power, in this case from the battery. And then the battery side connection is here, that gets the female connector in it. And those go with the open ends here. And then we put the other end. This is what will actually go to the battery tray. It doesn't have anything sticking out because obviously with the PAX Live you don't want to be able to easily short this. And the two of these connectors will mate together like so. These are a little sticky when they're brand new and not bolted together. And then they'll pull apart like that, and that'll make the connection. So now that we know that this is our battery side, we're going to go ahead and get out the soldering iron, and we need to solder a connector to these two ends. We're going to take our battery tray out of the way, fire up the soldering iron vise here on the bench to hold the connectors while we solder them. And I'll let you see how we do this. Now, if you're dedicating batteries to the trays, you could solder these ends directly onto your battery. Obviously, be really careful to not let them touch. Also, make sure you're clear on which is the end that you put the solder in. It's the one with the hole in the top of the connector here. That's the one where your wire will go in. So I like to put them in a mount here, sticking upright so I can sort of fill the cup with solder. And you got to get the tension of the vise just right where it won't fall out. Okay, we've got our two inserts. I've got the connector that I'm going to use that my batteries will plug into, which we're going to solder to. This will all make sense when you see it completed, which we're going to solder into this connector. I have the opposite of it, which we'll use just to sort of help hold things together and as a bit of a heat sink while we solder, because we always want the heat to have some place to go. But we're going to actually start with the cup first. And we're going to take some solder and we're going to fill this thing up. And we are going to solder these obviously outside of the plastic housing because these are going to get screaming hot when we fill them up with solder. And I just stick the soldering iron in there and I just melt a ton of solder into this cup. Like a lot. So I get a nice base of solder in the cup. Okay, I'm going to let that cool for a minute. Doesn't matter which I start with, positive or negative, and I'm going to strip about 1/4 of an inch of the wire. And then I'm going to do what's called tinning the wire, which means I'm going to soak a bunch of solder into the end of the wire. And I'm just going to use this sort of, these are called helping hands, little clamp to hold the wire while we get a bunch of solder into it. And again, soldering is like anything else. There's many ways to do things. This is how I do them. You might use flux or some other things to speed things along. This is how I do it. Works for me. Yet to, knock on wood, melt a connection in the air or have a solder joint fail. So do with that information what you wish. So what I'm doing is just heating up the end of the wire and getting a bunch of solder to soak into the end of the wire. And we're not doing this directly. The iron has a little solder on it because that helps transfer heat, and it's soaking into the wire itself. We're going to set ourselves up using the same helping hands. And be careful, this stuff gets screaming hot. These wires and all that get hot. I've worked with hot lighting instruments on television and live event sets for years. So I have like asbestos fingers, so I'm not very sensitive to heat in my hands. So be careful, this is a lot hotter than it looks. All right, so now we're going to get some solder on the iron, and we're going to heat up the wire and the connector and the cup, all of that at once. And I'll know that the heat's starting to transfer when I can touch the solder to the wire and it'll start to liquefy. Not quite there yet. And then I'm just going to make sure this whole cup is filled with solder. We get a really strong connection. We're getting there. Yeah, it's starting to melt and fill up now. And then this is going to melt the original solder we put in there as well. Yep, here we go. Push this wire down in as far as it'll go. Take the soldering iron out. We've got a big old cup full of solder there. And that is slowly going to cool and solidify. We're just going to let that sit for a minute. And if all goes well, it's still very hot. There's no solder spilled out of the connector anywhere because that makes it hard to fit into the plastic housing. But there's a whole bunch of solder and you've got a nice melted vat of solder in the end of the connection. And this mat is silicone, so it can take the heat. I'm just going to stick that over there so I can put the other connector in and do the same thing with the black wire. By the way, I always strip wire into the trash can because when you do so, inevitably you shoot little shards of wire onto the bench, and which is not a big deal, except that motors in our helicopters are essentially giant magnets, and you don't want a bunch of those little shavings to get sucked up off the bench into the motor. Again, we're going to get some solder on the tip, press it against the end of the wire, and then that's going to transfer the heat into the wire, and then we'll be able to, once it gets hot enough, just sort of touch the solder, not to the soldering iron, but to the wire itself. But this is 10 gauge wire, so it takes a little while to heat up. There it goes, see? And the reason we let it absorb this way is because now we're actually wicking the solder into the wire, which is what we want. That's what's going to give us a really good electrical connection. And then we have a nice coating there. All right, whoops, got a little too much in there. Now we're going to fill the base of the cup with solder again. Got a good puddle in there. And then we'll take this wire and use the helping hands to kind of get it down in there. And then we're going to start adding a bunch more solder in there as well. Keeping pressure on that. And this is going to melt the solder that's in the cup, the solder that's melted into the wire. And it's going to make a nice big old friction fit in here as well. And you can, as soon as I add it, I know you can't see this in camera, but it's just liquefying everything immediately. Okay, it's nice and glossy. That's pushed in really well. Okay, so the first thing we're going to do is prep our wires. Like I said, I only need about an inch or so of wire before I strip it. So I'm going to go with, and I'm just going to ballpark this about that much. And then I'm going to match the other one to the same amount of wire. Okay, so I've got two short connections there now. And I'm going to use, so my batteries in the 6 to 8S size use EC5 connections because it's easy to buy them with that connector already on it, and I'm lazy. But I prefer to solder IC5. So this is a connector made by Spectrum, Horizon Hobby, and it mates up to the EC5, but the IC5s I find much easier to solder. So I'm going to go ahead and use these. Now, the side that mates to the battery is the side with the male pins in it, and that will go to an EC5 connection like so. But when you solder these, it's always nice to have another connector to just help hold the pins in alignment as you add heat. And I always start with the negative connection, so I'm going to get the negative connection upright. You might see a little solder in here. This is a connector I've used before that I'm repurposing. So I've already tinned the connector side of things. Now I need to do two things. I need to get this little teeny tiny short wire through the plastic part that makes up the back half of the battery connector, and then we need to strip this just a little bit, maybe 1/8 of an inch, not a lot. We don't need a lot here to go into the connector, and we're gonna tin this connection in our helping hands this way so you guys can see it a little better. Okay. Same rodeo, a little solder on the iron, and then we're going to wick some into the wire itself as it heats up. There we go, and you can see it's now starting to wick in nicely. And if you tin this really well, it's going to make a very quick and easy connection. All right, whoops. We'll drop a solder hanging off the bottom there. Now we're going to use our helping hands to kind of get this close. Ooh, that's hot. Okay, you can see like already physically they're pretty much, whoops, yep, mated right up against each other. So really all I'm going to have to do now, because the connector side is tinned, this side is tinned, is get a little bit of solder on the end of the iron and just kind of melt the two halves together. So I'm just going to have some gentle pressure on top with some solder on the iron. It's going to melt the tinned piece of wire, and then that in turn will melt the solder that's in the cup of the connector. It's starting to liquefy now. If it doesn't quite flow fast enough, I can always just add a little bit more solder. Starts to flow. Just keeping some pressure there as it cools off. All right, while that's cooling off, we're going to go ahead and strip the positive side. Careful, this connection is hot. Even the back side is hot. Ow! See if I can hold it long enough to get the vise on it, because I'm impatient. Again, being super patient, slowly working its way into the wire. All right, that is now sufficiently tinned. So I got a big old accidental gob of solder that ran off there. I'm trying to get off of here. There we go. This is all screaming hot. We got to kind of let this cool. Okay, that's starting to cool off now. Okay, not quite. So we're going to have to feed this through the other side of our connector there. And then I'm going to take our helping hands and re-grab the wire. Here we go. So I'm going to have to hold it. Get things physically as close to the location it's going to be as possible. Whoops. Tighten this vise down a little bit more. There we go. Okay. We're in pretty good shape there. So we're through the back half of the EC5 connector. We're physically there. So really all I have to do, little solder on the iron. And then again, we're just going to melt through the solder on the wire. That happened quickly because it's still pretty warm. And then we've got to keep holding here. There we go. You can see the cup solder, how that whole wire just dropped into the solder that's in the cup of the connector. And we're just going to let a little more solder flow here. There we go. Now it's really dropping in. Just giving some more pressure on the wire. There we go. It's great. And it's a decent solder joint. It'll be nice and shiny. And now we just got to sit here and let that cool for a while. And then we will put it in the tray. So I'll come back once all of this is cool. I'm going to take this time to clean up all this solder and shenanigans off the bench. Okay, I pushed the jacket over it. So now this is covered and it's now cooled. So there you go. You can see one battery connector. This little white chalky stuff is literally the jacket got a little warm and melted some of the coating, but that's good to go. So now we can put our battery side together. I'm going to get this vise out of the way. So we get our two halves together here. And then we grab the two bolts that come with the battery tray here. And we will get this guy installed. And there is a little threaded receiver there, so we will put a little Loctite on these. So now we're going to go through the chamfered side, connector, and through the tray. Now I can kind of let go of things because that first screw is starting to hold things together. And pop the second one in. And then you want these good and tight because you're slamming the connector in and out here. All right, there we go. And as you see, that's going to pop up just like that. So now if I take my Success pack with my Velcro, and I can plug it in. And I'm going to have to think about how I manage things here. But that would plug in like so and be on the front of my helicopter. And I may change the way I do this. It's really easy to get more pins once I have the model finished. If I decide I want a longer connection and I want to kind of run it back here and capture it in the strap of the battery, I can do that as well. But now we've got, and there you go. So there is a battery with a connection. So this just unplugs like that. You get it all set up. And then you would plug, I could also shorten these leads in the batteries I'll use. And CG wise, this pack may be here, it might be up further. I could, you know, capture the leads in the side or here and then double it back. I'll figure it all out when I get to setting the CG. But there you go. You now have the connection. So we get to use the quick release, but we don't have to dedicate a pack to the tray. So we have a connector right there on the tray. All right. Okay. One last step here. And that is to install, as far as the build goes anyway, that is to install these handy, these are antenna guides. So when your FBL is mounted on the back, and I'm going to give you the full wiring tour in just a moment, these antenna guides is where you'll run your antenna wires to get them nicely in a bit of a V coming out the back on either side of the tail boom here. So these just screw in with 4 self-tapping screws. They're little 3D printed parts. They can be a little fragile, so be careful. There's 1 per side, and pretty straightforward how the antenna wire just sits inside these. So you'll have to figure out which one goes on which side, but it's pretty straightforward. The holes only line up correctly when you get them in the right side. So you should be able to get the antenna in here after the fact. So get your self-tapping screw lined up. Just get one in, started, and then the other. Okay, there's one side. Moving to the other side. Okay, and that is all there is to it. That is our antenna guides. Are all set. So once I secure, right now the fiberglass is kind of floating as I've been setting up and testing things. We're going to flip these around this way, and they're going to go inside the guide and kind of pop into the channel here, which may need a little persuasion. Looks like I kind of need to thread it in from the back. And then I'm going to put a little heat shrink over the end to kind of hold these antennas where I want them. But for now, I'm just going to kind of loosely start these. And that heat shrink is not included in the kit. Could do it with a zip tie around here, which is included in the kit. But I think heat shrink's a little cleaner. You can get some of these just cheap heat shrink kits on Amazon, lots of different sizes. Kind of just see what fits over the end. I think this square size here will be great. This looks like roughly 1/4 inch heat shrink. So what I'm going to do is take this piece, push it around the antenna, and get it to go around the end here. Kind of push the heat shrink flush with the tip. And we're going to have to be really careful heat shrinking this because obviously we don't want to hurt the paint job on the boom. So if you can put a physical barrier there to help save your boom, can get that heat shrink as close to far down as you can. In my case, I'm just going to use the blade here to kind of give something that has a heat stop. And I'm going to focus the heat mostly downward and away from the boom. And you can see we have our antennas sticking out at roughly 45-ish. And I could probably stick a little straw in there and get that a little better, but that's pretty good. All right, with that, we finished the bulk of the assembly. We're going to talk about electronics and wiring in just a minute. But you know what we got to do. Duh, put the canopy on. Come on. I love it. This looks awesome. This is classic SAB with some updated lines, this beautiful molded side frames, the nice accent here. And honestly, all of these cutouts and whatnot are really designed to move air around the motor and the components in here. There is additional venting to keep your ESC cool and the motor cool. Obviously loads of airflow through the sides of the canopy. And it just looks beautiful. A little bit of extra effort spent on the wiring, and wrapping in a heat shrink means it's all black and it all disappears. You don't see it through the side frame. There's no colored wire visible on my birds. I'm going to finish up the wiring and the setup, and then I'm going to give you the full tour of how I did it so you can see there's some unique wiring tools in here. Not so much tools, but some places to attach wires, and I'll go through all of that as soon as I finish just setting it up and verifying all my connections, and we'll be right back. All right, we have a fully wired up helicopter right now. I'm going to take you through it sort of one step at a time. I've got the blades bolted on right now. making sure everything is going correctly. So the main rotor blades should be going clockwise with the leading edge moving forwards. And then the tail rotor, as this goes clockwise, will go counterclockwise. Same thing, obviously the leading edge of each blade should be traveling forwards. Pretty straightforward stuff, quite standard for helicopters. So let's talk about the wiring of this helicopter. I'm going to take you through it. I'll give you some close-ups and show you what I did. So on the ESC side, on the power connections, they go outwards from the ESC, down the side of the ESC, and then straight into the built-in battery connection right here. Motor cable wise, the motor wires come out, go underneath the ESC tray where they are connected to the motor connections, and then those are sucked up tight against the ESC tray with this zip tie, goes around the front of the ESC and then underneath picks up the motor cables as well. This back ESC here just holds the, this back zip tie here just holds the ESC in place. My ESC cables are bundled in kind of a rigid heat shrink. They go under the frame here. I've got them wrapped in this Velcro here to keep them from chafing against the frame. And then they come into the built-in cable tray, which is great. The only thing I have running in this cable tray right here is my ESC cables. So they are jacketed. I wrap them in this soft Velcro strap and then a zip tie, so there's nothing sort of abrasive that can chafe or rub the wires. So ESC cables come in here. I have another piece of heat shrink coming off just to hide the color of the wires. And then that tucks back here to the FBL. Servo wires. There are a couple of unique spots in the frame of this helicopter where the wires run. So these two Cyclic servos closest to the main shaft come down in a Y. They're wrapped in a piece of soft Velcro and then zip tied to this position. It's part of the central bearing block here has a specific keyed hole to hold the zip tie, which is great. And then there's this nice little strap that goes over into the main transmission tray that you can combine all three Cyclic servo leads underneath. I've got some soft Velcro in there as well. And then all of my servo leads tuck back into this top section of the boom. Do you remember there was that sort of little bit of carbon plate extension on the FBL? My wiring, any bit extra, which there's very little extra, sits on top. And then I have this soft Velcro piece right here as well. And what that main purpose is just to stop these wires chafing against the top edge of the boom. So it just gives a little bit extra. And I have 2 layers of that soft Velcro in here from stopping that. And then my antennas just wrap around and use the stock antennas. I did stick a drinking straw kind of into the end of each antenna. Keeps these pointing out what more of a 45. They were kind of flattening against the boom. So a little drinking straw like coffee stirrer in there as well. Holds the wiring, and it's really that simple, super simple helicopter to wire. Do spend some time, like I said earlier, getting the battery connections to line up, you know, loosening, tightening things until you get that right. But plenty of room, very simple to cable helicopter. You could, if you wanted to, take these servo leads down into this cable tray and all come around one path if you wanted to, but I wanted to use the sort of inbuilt wiring features. With that, there's nothing left to do but stick the canopy on this thing and see what the completed helicopter looks like, and check the C of G, which I haven't done yet. So if you don't know, checking the center of gravity on a helicopter ensures that the helicopter is balanced on the main rotor and that it's not going to be inclined to sort of lean one way or the other in terms of balance. It makes it pirouette a lot smoother, as well as do a variety of 3D maneuvers in a more balanced fashion. All right, wow, this looks amazing. Sorry, my battery connection's hanging down here. I just have it disconnected from the tray right now. Look at that. What a sharp looking helicopter. Honestly, it looks just like the stock Il Goblin Pro 700, plus the molded frame sides, but it's just nicely shrunken down in 580 form. But how do you check the CG? This is really simple. So you're gonna grab the main rotor with your hand, and you're gonna, basically I'm resting the rotor blade against the side here, and you can see it's very nose heavy, so I've got a lot of room to move the battery backwards on the tray. And we're just going to keep repeating this, moving the battery backwards on the tray until we get it to balance. So that's great. I would much rather have a helicopter be nose heavy than tail heavy. It's a lot easier. You can only move the pack so far forward, but there's lots of room to move it back. So I'm going to mess around with that right now. Pop it out of the tray, just like so. We'll undo the Velcro, slide it backwards, and we've got, it was pretty nose heavy, so we've got lots of room to slide this battery backwards. I'm even going to be able to move my battery straps, I think, to the next slot back. And this should put my 6S stick right in the middle of my tray. But let's see how it does. Oops, I forgot to incorporate the power lead here. And I'm just leaving this disconnected from the tray so that I don't have to deal with the helicopter being powered up while I do this. All right, with that connected and further in the tray, let's try that again. Yeah, you can see it's dipping just a tiny bit nose heavy still. Much slower, so I've got room to move it back even more. All right, you can see now that we're much further back on the tray. Okay, let's take this again. And there we go. No more tilt. So with that, that is our center of gravity dialed. Now I'm going to just optimize the battery tray, maybe get some more Velcro straps on there in the right spots. But look at that. This is the IL Goblin SG590. Absolutely beautiful looking kit. Thanks again to Enrico, all the folks at SAB, Sean Hall at HeliDirect, and everyone else, Sam, Patrick, all the guys at the warehouse at HeliDirect that made this possible. Being able to get this kit to me so I could do the build video. So thanks very much. Again, my name's Nick Wisdom. Any questions, feel free to drop them in the comments. I'll try and answer them as best I can. I'm going to go ahead and finish the setup, do the maiden, and we'll show you some footage from the helicopter's first flight in just a minute. Thanks a lot for watching. Up, down, forward, backward, left, right, corrections, correct, correct. Correct. All right, let's maiden this thing.
0. Auto rotation. Bank 1.
Direct!